a minute, sir.
Sure.
Within 1 minute, we will start, sir.
No problem. Take your time. Yeah.
So, dear participants, good morning to everyone. So, today, day 3 session. So, today on the day 3, there will be a 3 sessions. First 2 sessions, the morning sessions will be taken by Shiva Kumar sir. So, I am very happy to introduce Shiva Kumar sir. So, Professor Shiva Kumar sir Mathapathi is an adjunct faculty member at multiple universities, including the University of California, San Diego, Sonam State University, Santa Kerala University. Sir has nearly 25 years of industry experience. Sir is an accomplished research and a co-founder of Due Mobility Incorporated and Extrans Solutions Private Limited. Sir his teaching and research areas including IoT, ML, AI, cybersecurity and blockchain. Sir is the co-founder of Extrans, which is a leading company in establishing Center of Excellence. He is the key contributor in creating tutorials, workshops, practice, use cases for smart cities. Sir, it's my privilege to introduce sir. So now I will hand over the session to Shivakumar sir. Sir, please continue the session, sir.
Thank you very much, Professor Bhavya, for kind introductions. Appreciate. Good morning, everyone. Apologies for the delay. Actually, I was trying to get this Microsoft tools running on the Mac. Always you have a challenge, right? So, good morning, everyone. Welcome to the second or third day session of FDP. And before that, I would like to thank to Dr. Murli for giving me this opportunity. We started conversation about a month back, and then we enter into this, kind of an FDP arrangements. So I'm pleasure and happy to share whatever learning research I have been doing with multiple universities, like Professor Bhavya said. So without further ado, let me share my screen. I will just to the benefit of video for the bandwidth, I'll just switch off the video if you don't mind, and I'll keep the audio and share my screen. So that way, we can have a meaningful communications. But I will come back during Q&A sessions, All right. Okay. So here is that. All right. So let me pull out my screen here. All right, so let me share my screen here. Am I able to see my screen, Dr. Bhavya?
Moving on, just briefly tell you about what is.
Yes, sir. Yes, sir.
Yes, sir.
Okay. All right. Thank you. All right. So is the screen okay?
Okay, sir. Okay, sir.
Yeah. Please, please let me know if you're not able to see the screen. Okay, because I'm not able to see the the screen, the chat window, but just shoot out, if you're not able to see the screen. Okay.
Okay, sir. Sure, sir.
Okay, good. Thank you. So yeah, my name is Shiva Kumar. I'm the adjunct faculty, like introduced to me. So I'm based in California, and today's session it will be supported my colleague in Bangalore. He come in the second session. As we speak, he has been working on setting up some demo. So I told him that let's show some kind of a demo on the blockchain and related on the Bitcoin. He would be joining the second half. Okay. So let's start about this topic. Today's topic is blockchain in IoT connected devices and use cases. So this is my fourth version of presentation for the FDP program only. Few of you might have attended that, but if you are going in a sleep mode, that's fine, because idea is to share. Of course, whatever learning we have done it from the FDP, I fine-tuned those on my slides. So let's see, what's the blockchain and how we can connect to the Internet of Things. Right? It's a very interesting subject, right? Blockchain. One hand, you are talking about the security. Other hand, you are talking about the number of devices, right? It's going up. So security is inversely proportional to the number of devices. I mean, when I say inversely proportional, the actually percentage of security is normally it's straight away it will not happen. It's directly proportional to the devices or number of connected devices, right? It's inversely proportional. The reason I'm saying is that the more more devices you go, you need a lot of security aspects to that. So let's see the blockchain itself. I just put some kind of an a pyramidal diagram here. The blockchain is basically nothing but a data science or a data structure. So that data structure has got a different dimension to that, right? One is the transaction record, and in a secured way. You are keeping all the transactions, what it happens from a block 0 to block n. You are keeping all everything transactions, what they call it as a ledger in blockchain world, right? I mean, they've taken it from the conventional way of recording everything like a ledger. You go to the bank or railways or any other corporate, they used to have a ledger, right? Now ledger has been changed to digital. Now digital, how we can make that into a meaningful, meaningful platform to that. So then another thing is that it is transparent and decentralized. So it's basically it has to be transparent. From one block to other block when you go. So it has to be very transparent. When I say transparent, for example, you take the currency, right? You take dollar or euros or rupees. When you have the currencies, we don't know what happened in the bigger picture, right? We know what is happening in the from us to the bank, from when we're spending, we know only that limit, but we don't know what is happening in the bigger picture, right? Whereas in this blockchain platform, everyone knows what is happening. Only they don't know how much they have, how much they're keeping it, because that is all personal data, right? So it's a very transparent, ledger-based. Everyone knows, what is happening in the whole transaction there, and it is decentralized. It's basically kind of peer-to-peer communications. It's not going to one centralized. Just imagine a railway reservation, right? You book it and then it goes to a central computer and everything will log on to the computers. And they say that, okay, 8 p.m. we are shutting it down. So 8 p.m. at central computer shut it down. All the state, district, taluka, wherever they have the offices, everything will get shut down, right? From the centrally operated. Whereas in blockchain, it is a decentralized. It is actually, even though central computers are the main one switch off, but the others will still remain open on that. So that's about the blockchain. It's transparent, decentralized, and it's a secured way of transaction. So we have been doing secured way in a very conventional way, that SSL security. But I will come back to what the SSL and how we can implement under the blockchain here. Now look at it on the right hand side. I have an Internet of Things, right? One is a blockchain and Internet of Things. The devices are going up. So today we are talking about the billions of devices, right? 50 billion devices. Yes, it is possible. And for last 3 months, because of this COVID outbreak, we are not getting correct information how many devices have been into traces. But by and large, till December 2019, we really had a good growth, in terms of connected devices. Every day it is going connected, right? Each one of us carrying at least. Yes, please. Anything? Any question? Professor Bhavya, is it okay? I can go ahead.
Yes, sir. Please continue, sir.
Okay. So
Sir,
yes, Internet of Things. We have the billions of devices are getting connected, and then it's now how do we get the security? The more devices goes, now security demand will be more, right? Even one device break something, then we have a challenge there, right? So we have to implement this secured connections there, because it is possible, it happened earlier, in one of the place you might have read, one place in yesterday also I was just sharing this example in place called Las Vegas, which is an entertainment city, which is in Nevada. So there some hackers basically went into an aquarium. Basically all the Las Vegas, you may be knowing, it's more of an entertainment city. So they have casinos, all the casinos, and they had one aquarium where there are fishes are there. They have connected the internet to change the color, change the color of the water, or put the, make that fish little, roam around and all. But some hacker went into that, aquarium, and then logged into the, the main enterprise server on that, so that way, so now there was no security. You could able to easily enter into the IP address of that one. Once he get the IP address, then he logged into the main server and then get all the data there, right? So that's kind of an security leakage or such of this thing is happening. So we need to, very clear on the aspects of what we have to day, and then how we can implement security on all these aspects. That's a blockchain will come in picture on that. Okay, let's see. I think you have been getting a lot of information on the blockchain. So it is basically just to give certain foundations what the blockchain is about. So it's invented by a person or a group of people, and it's basically main paper published by Satoshi Nakamoto in 2008 to serve as a public transaction. He just published a paper, and that has become today, one of the prime security area for a few of the initiatives, right, including the Bitcoin, which is I think my second session talk about that. And then we have the digital. It's a digital stamps. No tampering. It's like a notary, right? So whenever you want to have any documentations, so you will go to a notary, and then he or she will make the notary, and then it will go to the court, or you keep a copy. Court will keep the copy. Government or whoever is the home department or whatever that they keep the copy, and there's a kind of a timestamp. That's similar concept in this one. Then it is a distributed ledger. It is a distributed ledger means everybody has got the ledger, so it is very difficult to change. So you cannot change, and if you change it, it's a ripple effect. Everybody will get a notification on that. And each block has data and hash, like a fingerprint approval, right? Hash is nothing but like a fingerprint. You just put your fingerprint on the hash application you take. It has you will always know that from where it is coming and from where it is going, right? So it's for Bitcoin example, right? I'm going to take it in this following session, possibly with a demo. So it is as well as it comes to the hash, So let's see what are the different components of blockchain. What exactly is the blockchain, and then we go on to IoT components, right? Blockchain components, IoT components, then merge together. We'll see that where that intersection or what are the use cases we can do it in a IoT devices. So it has a node, a user or a computer with a blockchain. So it's like I have one node here, Mac machine. So this is my node, right? You all have one computer which is also a node, whether a computer or a phone, a smartphone. Now smartphone is also like a supercomputer, right? You have all the ingredients on that. They say that this is compared to a 1990s supercomputer. So then there is a transaction. A node is nothing but a PC or any hardware which within the blockchain. No? Then you have a transaction, smallest building block of a blockchain system. Whatever transaction you do, it could be your currency, or you send the data, IoT data to that whole blockchain. So that is one transaction. And then a block, a data structure, used to keeping a set of transaction which is distributed to all nodes in the moment. So one block, so you keep that data structure. It's like a data science in that whole ecosystem. And then chain is nothing but a sequence of blocks in a specific order, right? So you have to put in a specific order so that we know that which block is coming, which chain is coming into that. And very important component is the miners. This is the very specific nodes which has got a high power of your GPU, which perform the block verification process, right? So they are all the miners. They can mine as well as they can build. If you want to do a miner, it's a very, very expensive proposition. So you need to have a very high-end GPU on that, and everybody has to approve that, right? You are a miner and they start taking that. It's like a gold mine, right? So gold mine is not that simple, right? It's a specific node there. And then the consensus, set of rules and arrangements to carry out blockchain. This is the beauty of the security system, blockchain, how you take the consensus of all the people on the networking, right, for all the nodes over there. So then what is a blockchain? Again, I don't want to take much time on that, but just want to give a very brief foundations. So it cannot be corrupted. The features of blockchain, it cannot be corrupted, right? You have the data, you cannot have a duplicate, right? If you want a note, rupees note, or dollar bill, we call it as. So we cannot really corrupt it. You cannot even see in the notes is a simple note, right? You can always print it. Whereas here, digital, once it is locked, it's nothing. It's nowhere. You cannot copy that, right? Even if you copy it, it cannot be. It's actually encrypted, or cryptography, what they call, within the computer, within the high-end CPU. So it's like a hard the encryption done in the computer. You cannot be corrupted. And decentralized technology, like we talked about it, right? Is all decentralized and enhanced security. Yes, definitely is an enhanced security. Everyone knows what is happening in the whole system. Okay, if you are not obeying the rules and regulations within that one, then you are out of the blockchain, right? You won't be allowed there, because they have to follow certain guidelines and certain standards on that. And distributed ledgers, right? All the ledgers will have a distributions, the pointers there, no? Distribution ledgers means block 0, 1, 2, 3. All those things are in the distribution way. You can make it. I'm going to walk you through that. So now how blockchain works, right? I'm just taking the blockchain and jump onto the IoT there. So blockchain is a transaction is requested. That is, example is that now you want to buy a product from Amazon. Now I'm just giving one transaction. Okay, you go to the Amazon this thing. Okay, I want to buy it through my Bitcoin or whatever the cryptocurrency you are having it. Okay, you go there. And a block that represents the transaction is created. That actually whatever Amazon you are creating, a block is created for that. Okay, means okay, now XYZ from Anantapur, he is actually requested the transaction. It requests the transaction, and then a block is created from that Anantapur. I'm just taking that because this JNQ is located there. So I just take that Anantapur you located. And then the block is sent to every node of the operation, so that I know if I'm in that networking, if my Bangalore team is in networking, if my Santa Clara University professors are in team, so everybody will be notified that some transaction is happened from Anantapur, so let's everybody who are in the network, everyone will know that, okay, this transaction has happened. Block is sent to every node in the network. I have to be in that network, and if I'm not in the network, then you are not in the system, right? And nodes validate the transaction. All the nodes, I have to say that, hey, this is correct, basically this particular hash, whatever I'm getting it, it's a valid hash, I'm getting it. So let's, approve it. Everybody has to approve. Everything's happening in a fraction of a second. You don't have to wait for that bureaucratic process, right? It's everything's happening in a matter of microseconds or milliseconds. Because all the systems are capable of handling the transaction there, right? It's validated, and nodes receive a reward for the proof of work. So nodes whoever is selected from Anantapur, he or she gets some kind of a node receive a reward. Okay, you proof of work is there, and block is added to the existing blockchain. Then the block is added, and then the transaction is completed, right? So you are requesting it, and going from here. I wanted to get a pen here. Okay, yeah. So here, so you are starting from here, and then sorry, it's not the right pen. So you are starting from here, okay, and then moving on to here, and then you are continuing this transaction, right? So this is the whole operations here. You have to follow this complete operations. So this is your place here, and this is I'm just saying Anantapur, and then your transaction is complete. You get back actually, okay, transaction is complete. Then you get some kind of a loop here, right? So you get it here, okay, transaction is complete here, right? So that's how the the blockchain it works there. So okay. Now it also works on a concept called the hash of blockchain technologies, right? So there is each node. You remember that it creates an hash. It's like a fingerprint, right? I'm creating a fingerprint each node. Okay. So block 0 is one node, right? Like same example you take Anandpur, when a transaction started, you created an hash. I just given the number as a 1EB1. Each one has got about 8 bits. That means you can have about 32 bits. You can monitor it. 0 to 31 bit. If you take, you get a long this one in the demo. Hopefully, I'll be able to show that what that hash looks like. We will try to bring that one. So what happened? This is hash. Now it goes to the next block. So what happened? Just imagine notice here. This hash will be, there are two columns here. One is the hash, normal hash of that particular one, and the previous hash. Okay, so you cannot repeat that previous hash. You cannot change anything, right? See, this is the previous hash here, and then previous hash comes here, right? And this one will become here, and then whatever the n comes here, n minus 1 comes here, right? So it's basically it's a daisy chain, right? So this one I'm giving it here. This one I'm going to do it. So just imagine if anybody changes anything in the whole block, it really get corrupted, and whole system will get corrupted there. So you might have noticed that initial block doesn't have any input, right? There's nothing coming here. This is nothing is there, right? Here you see here, there's nothing is there here, and I just put a dash mark here. There's nothing there. So that's why we call it as a special block. We call it as a Genesis block, so that is a Genesis block. We'll talk about that. So any change of data in one block change the whole hash program, and not an, I'm just reading out on the bottom line, valid data for the subsequent blocks. So any changes you make it, even a 1 bit you change, it's not an valid data. The computer doesn't recognize at all. So that's the very, very hard code. And it is a complex algorithms. No, it's not that simple algorithms like your I thought machine learning, artificial intelligence is a complex, but this has really got, because this need to be hard code. Yes, ma'am.
హలో సార్ ఇది హోల్డ్లో వెళ్ళి ఆఫ్లైన్ అయిపోయింది. ఓకే హలో
Yeah, is it offline? Sorry. Is it offline? Sorry, ma'am.
Sir, you are audible.
Okay.
Please continue.
Okay. Okay. Thank you. So and then 2DC, and then we have this one, right? And then this is a peer-to-peer network. This, remember, this is a very important aspect in excuse me, in blockchain. It's a peer-to-peer network. That means, I think you all computer engineers or engineering background. So peer-to-peer network is like this, right? It goes from four. I just showing a box here. So it communicate to here, and this communicate to here, and this communicate to here, and this communicate to here, right? This is your node 1 or node 0, and this is node n, right? Node n. So this is node n, and everybody knows that what is happening there. Even though it's the last node, they know that what is happening. So this is the communication is happening from one to other one. In fact, I remember when you used to have a Linux system, you used to have a peer-to-peer, or you to have a centralized, right? One Ethernet, and then you transmit it to the all other nodes there, right? So now let's take, IBM is putting lot of resource, and they're investing onto the IoT with the blockchain. They're really putting the their energy and their staff to get this IoT with blockchain. So I was fortunate to be part of one of their panel discussions sometime back. So IBM fellow and myself and two other companies were there, and we discussed a long these things in Santa Clara, California. So we had 1 hour session. We really had a very good discussion. I learned a lot from that forum, so where I was one of the panelists. So we talked about that. Okay, what is the IoT? What's the blockchain and all? So he says the IBM story is basically, I mean, you can read this. It's basically a distributed replication of IBM blockchain, and without the need of any central computers. There's central control. So all business partners can verify each transaction, preventing disputes and ensuring each partner is held accountable. That is very important. In the blockchain, everybody is accountable. Whether it is a corporate or is a government or it is individuals. Everybody held responsible, and there is a mechanism that when the author announced this or shared the paper, there is definitely there is something meaning on that, right? He cannot just publish that. So there's a meaning to that, and each block will have a some kind of an accountable, and everybody is accountable in terms of sending the data, in terms of maintaining their system. So then this is what are the three key benefits of using blockchain for IoT is that we are building the trust, right? Trust is very important. When it comes to the IoT, it's a trust is one of the any factor for that matter. Now, in my second session, I'm going to cover up that value, money. What is that actually? Trust is nothing but your money, and then you have the value to that. And then what is the trust, right? It's money plus value is money equal to value equal to trust, right? So you have to be really trusted. So even today, when I teach Internet of Thing at the school, at the university, and I also do the workshop for the smart cities along with a few professors. So when you go to the smart city projects, for last 3 months the activity has come down, but otherwise every month we meet. And then we discuss about what smart city project we can do. The biggest question they ask us in the smart city whenever I go, how do I trust these IoT devices? Are they trustable? Can that IoT data, whatever you're accessing, can it affect my legacy server or legacy systems, right? It might just immediately come down, and then it might affect my server. So is it enterprise then? So those kind of a trust factors are there. And reduce risk of collisions and tampering, and reduce cost. Yes, obviously, the number of devices are going up every day. So if you say that, okay, each device I want some percentage for the security, because remember all these IoT connected devices, they are all low cost devices, right? It's $2, $3 kind of a sensor, right? We are not talking anything more than that, right? So we all, we had to reduce the cost by removing the overhead and associated with the middleman, because there is a middleman, right? When I say middleman, when you say take the currency, there is a there is a bank, centralized bank, and there's a government, right? So those aspects, they'll also have their own overheads, right? One example is that whenever you go for a mortgage here, I'm just giving an example. If I go for my home mortgage here. So basically, government will give it to the central bank will give it to the regional bank will give it to my local bank. So by the time it comes, actually it's 4-5% is gone there in the finance cost, right? The government will give to the central bank, maybe at, I'm just giving an example here, I don't know, I need to see the prime rate. There is 3% or 2.5% on their investment, right? So if I want to borrow, then it is going to be, for me it's going to be 4% or 5%, right, on the annual percentage, the APR level, right? So just imagine that 2% has gone up there because the middleman, that whatever the bank, government, everything. So reduce cost, then accelerate transactions. Yes, the speed has to be improved speed there. So those are the three building characteristics of a blockchain. So very nicely said, IBM fellow. I'll just read out for the benefit of everybody. Business do not exist in isolations. They are connected to customers, suppliers, and partners. They exist in countries around the world and have to comply with the regulations. The networks are not static, and over time they morph because of business acquisition and mergers. Finance, risk management, healthcare, insurance, and the Internet of Things are some of the other systems that are poised for the dramatic change using blockchain networks. So what Jerry, IBM fellow, shares is that it cannot work in isolations, right? I mean, I cannot work in isolations. You all cannot work in isolation. Everybody should work in cooperations, in a community, or in tandem with the common goals there, right? Then only we can actually, the microeconomics or whatever we're talking, that become more meaningful, right? Otherwise, if I am working in isolations and you are working in isolations, it doesn't work that way, right? I don't know what is happening. It's like gone are those old days, right? To keep everything, money, gold, mine, everything under some separate. Other person doesn't even know what is happening there, right? It doesn't work with, right? We have to share, we have to trust, and build a peer-to-peer or platform there. So that's about the blockchain. Now let's go what's happening in the IoT. Let me take you to the IoT world. What is I know few of you are already, or most of you are already know about the IoT. But let's see what's the IoT is happening. So just to set the pretext of the definition of IoT, there are different kinds of IoT definitions are there. Someone says, if you ask any electronics engineer or electrical engineer, they say IoT is nothing but connecting devices, sensors to the on the what you call microcontroller. Someone says that if it's a computer engineering or a computer science, they say that no, I don't care about the hardware, I don't care about the sensor. As long as the data come to my cloud, I'm done. I'm the software engineer. That's my IoT, right? So that's not so. This is the definition from IEEE. I have taken it. So that actually it says it's a self-configuring and adaptive system consisting of networks of sensor and smart objects whose purpose is to interconnect all things, including everyday and industrial objects, in such a way as to make them intelligent, programmable, and more capable of interacting with the humans. So that's this is from the IEEE, unbiased definition of IoT. Combination of everything, right? Objects, you have got human being, intelligent, programmable, everything is there. So blockchain also come few of them, like it's a programmable blockchain, then it's intelligent systems, then capable of interfacing with the humans there, right? So now IoT, it is evolved over a period of time. Number of devices have gone up. Number of devices used to be less compared to the number of people or number of them. But now over a period of time, it has gone up, right? Let me take a another pen here. So as you can see here, right? So 2003 we had a number of people were more and the devices were less, yeah, right? 2010 slowly it went up, and 2015 it went up, and 2020 we have at least 3 or 4 times than the human population, say, right? 50 billion devices we're talking here. So it is definitely it is happening. So when you have the number of devices, then obviously more demanding, right? So on the right hand corner, I have a chart which shows the era of computing. How this era has come. I don't know, in this room, sure there will be at least few of my senior colleagues and colleagues. They will know about this fixed computing, right? They used to have a fixed computing, right, where just a hard disk, and then came the floppy disk, right? 5 1/4 or a 3 1/2 floppy disk, right? And then came the CD-ROM, and then we connected to the cloud. Internet came. It's a very version 1 internet or a 1G internet or a Ethernet or a 0.5G. Now today we are into 5G area, right? So 95 it was like that situation, and 2000 we slowly moved on to bring your own device, right? That's a mobile device, right? You bring your own device. Everything is sitting in the cloud, or everything sitting in the now we have the App Store, Google's Play Store or the Apple Store. But earlier we used to go to the operators and keep all the applications, right? We used to go to the operators, whether it's a Reliance or whether it is a Bharti, I think. So Bharti Airtel. So you used to keep it there, right? Now everything is in the bring your device. Bring your laptop, bring your mobile, and then you access the data. You don't need to put everything on the computer. So now 2011 we have an Internet of Things, which is a number of devices have gone up. So then IPv6 came in picture, IPv4, and then Internet of the Cisco is now 2020. This era is that Internet of Everything, right? Which is a people, process, data, and things, right? All the 4 parameters combined, we are calling it an Internet of Everything. This is actually coined by Cisco's previous chairman John Chambers, right? Yeah. So and then this is about your revenue here, $1.2 trillion. What they're expecting, it is happening actually. It is happening. Unfortunately, COVID-19 has hit back very badly, but I think we should come back. I think what the experts are saying that things will improve upon in everywhere. So we should come back, and it will take some time. So step by step, they're taking the process there, right? Yeah. So let's move on to the schematic diagram here. What the IoT looks like. We talked about the blockchain, what it looks like. Let's take a look on the IoT schematic. So I just tried to put all the blocks in the block diagram here. So we have a sensor, right? So then we have an I2C, UART, and SPI interfaces here. That all the sensors are connected to the I2C, UART, and the serial peripheral interfaces. So basically, you connect those sensors to an IoT hardware platform, which is a Raspberry Pi 3. I just shown here. It could be anything, as long as it's a microcontroller. You can connect these devices to that, and then it sends the data to the cloud through an MQTT or an HTTP protocol, right? It connects it there. So it's a temperature, humidity, CO2. It connects there, and then you display the data on the cloud. So that's your IoT. Now, what are steps involved in that? You have a device driver software, you have web interface, API, everything you got, right? So now our blockchain, let's see how we can implement the blockchain into whole aspects to that, right? How we can really look those data and monitor those. So now, why blockchain in IoT applications? Why? Because first of all, we have challenges. It's it's not that straight away we can implement the blockchain in the IoT devices, because they are all tiny devices, right? These are very constrained devices. We cannot really put blockchain heavy software, Ethereum software or whatever you talk into devices, right? We put it on a Raspberry Pi, and then my analysis is that somebody has to write really an algorithms, very fine algorithms, I mean, it's like any other concept, right? We have a cloud, we have a desktop, and then you have a mobile phone, and then you have a sensors, right? So now this whole blockchain, we are talking about the computer to computer, that is a peer to peer, the PC to a PC. But someone has to write some software or algorithms to handle these sensors, right? If you want to do a blockchain implementation. So I will show one. No, this probably we don't have a demo here, but next one we have a demo. But I have a pictorial diagram, how we can implement the blockchain in IoT platform. So here, now today we are doing the secure sockets layer, right? We have some kind of an secured layer here, right? We connect from sensor to the applications through some kind of an API. We get it, and we the application program interface, and then we identify the devices within this Python programming and connect it to the applications here. So now so what we have a sensor here. We write a small Python programming here, or a small embedded C programming here, and then sensor connected here. So, but how do we make it secure or authentic? So we have some kind of an layer which they send you the APIs. They send you the APIs, and then you integrate that into your Python coding or your embedded C or Java, whatever you're using it. You write that program, and then you upload it to the cloud. So that is kind of an secured sockets. You can just secure some secured layer. You got it here, right? So hope everybody understand that. Let me show one, a cloud. What is that API and how it looks like the API? We use the ThinkSpeak to connect. So let me go to the website here. Okay. So this is the one. So I want to go to a website here, which is called ThinkSpeak, right? So I'm going to go to a ThinkSpeak network here. So in this ThinkSpeak network, this is an IoT platform, right? This is a ThinkSpeak for IoT projects, right? You can connect all your devices. I don't know how many of you use the ThinkSpeak. I'm sure it's a very popular one for the academia. So what I will do is that I will go to my login here. So some reason network is very slow here. Okay. So you have smart connected devices, then algorithms here, as you can see here. So what I'll do is that I will log into my account here. So I'll go to my cloud here. So this is my all the data I have logged in, right, from my IoT devices, right? So I'll show what IoT platform we have. So these are all my data here. I was demonstrating for one of the IoT class, then I just logged in here. So for example, we have a smart environmental monitoring, right? So you have the data here, right? You have a temperature, you have a humidity, then you have the light, you have a gas sensor, temperature, and moisture sensor, right? All those data are there, right? So June 19th, I was just giving a demonstration here, and this was also June 19th last week. We had a one conference. So now, let's see what is that. So these are the data coming from the IoT hardware, right? We are connected the temperature, humidity, then light and gap. So what is that? How do we secure it here? So normally what we do is that we get an API keys here, right? So or you can go into the more on MQTT here. I'll go to the my profile. The MQTT, right? IoT, all the IoT devices are connected to the MQTT. This is my API key, right? This API key I will embed within my code, and then it becomes some kind of an identification or some kind of an secured, right? If I'm not adding these keys into my code, then it will not connect, right? So like that. So this is a secured way. This is what we are doing today, right? Of course, if you go to an Amazon Web Services or you go to Microsoft Azure or IBM Bluemix, they give you some certifications, right? Half page of certifications. You get that and then embed within your code and then upload the data, right? So that is the normal method we use it, right? So then you have a different channel here, of course. So you see my channel here. So then we did some applications here just to give you we did on COVID-19 monitoring systems, right? Social distancing, monitoring social distance. Now, what we done is we have a proximity sensor. We actually, if somebody is coming below that 6 feet or 182 centimeter it comes, then it gives you some kind of a buzzer, right? Or it gives some light indication saying, or LED indication, somebody has come, less than 6 feet. So we had to take care. For example, this one, I've tried it for several times. So how many people? 1, 2, 3 people have come. You see here reading motion less than 6 feet is a 3 people, no? So this one again, how I did, we actually written a small Python script. That Python script we added these channels here, right? The API keys from here we added the right API keys here, right? The keys here. Okay. So this is how we securely we do that. Of course, there are some this thing out there. Good thing about MATLAB is that you get a lot of MATLAB analysis and I will not go through that, but just keep it there. So that's how we connect, right? You take those API, put it under code, and then send it. But let's see what blockchain does, right? Yeah. So now, so this is how we're doing it. But here we can do that, but can we keep that Moore's law? Moore's law. Hope you all know that Moore's law is Gordon Moore from Intel. So one of the founder, one of the key person for making this Intel to that extent. So he predicted that the number of transistors, will grow. Every 18 months, number of transistors go double in a silicon chip, right? That is what he predicted, right? Every 18 months, number of transistors in a silicon goes almost double, right? That's what he predicted, and it is happening there. No, can the blockchain or the security, can we maintain that? That's a challenging, right? We can maintain it. It's not hard and good, but as long as you have the money, you have the roadmap, time to develop, we can maintain it. So another possibility is that yes, you can invest on embedded or encryption or decryption, right? You can always do it within the chip, right? You can just tell them that, okay, encrypt my SoC, encrypt my integrated circuit. But that is going to be a very, very expensive proposition. No? If you want to build a chip, I know now it has been reduced, but when I wanted to get a chip fabricated on one of the company for another project, so ST Microelectronics, I can take that example. That time ST Microelectronics and Hitachi, they had a collaboration. ST had a foundry and we were working in a project. So those time it used to be $800K to $1 million to get one chip assembled. Of course, once you make it, then you can make millions, billions of devices, right? So that's the propositions, right? I mean, when I want to go any chip, so the number of which actually very, very expensive proposition. Yes, some people might be interested now. Some people have taken the initiative. Some company have taken initiative. I don't know if you see that yesterday the Apple Developer Conference, Apple has announced that they are going to come out with their own chips, right? Own chipsets for their CPU, for their iPhone, for their wearables, even for the 5G, everything they are going to launch their own integrated circuit, right? All this time they are using the Intel or the Qualcomm, but now they announced that they want to go for one of their chips. But maybe the cost might come down. We don't know, but Apple is always an expensive proposition. So just to give an idea, so that is actually good security. We can do that. I like their model, because they want to bring it everything, but sometimes it becomes pricey, right? I mean, we have to follow their pricing model. Okay, so that's about that thing. Now the IoT and blockchain, is not sleeping during this COVID-19. It is very, very active. Some of the companies they are using this blockchain to have this COVID-19 mass testing. They want to implement in a secured way. They want to see that how that mass testing can be monitored. It's some of the press statement I put it here. and someone is using it to collect some of the genetic data for 500,000 patients worldwide to date. So they want to get real informations to the community or to the hospital port or anything. So there are some references there. You can go to the Cointelegraph paper. You will get more details about how this COVID-19, how blockchain and IoT is helping in under this COVID-19 break. Right? Okay, now let's see how do we implement it. So we have a temperature. See, basically, now how do I get the IoT into a blockchain? Now how I can take it? Basically, what we are trying to do here is we are trying to get the Ethereum software onto our kit. So before that, let me show one IoT the development kit, what we have and what we have been working on that. Let me see that. So let me get that kit for you all. Okay, all right. So maybe I will just put my video here. I'll just show what IoT development platform and then switch off the video here. Okay. So sorry, actually I have a green screen here. I thought, oh, I may have to stop sharing here, right? Okay. Then I can. So, okay. So now I don't know if I can see that in the camera here. Hope you can see that platform there. Dr. Bhavya, can you see that?
Yes, sir. So we can see.
Okay, so this is the IoT platform. We have
It's visible, sir.
the Raspberry Pi board, as you are familiar with that. Is it seen in the full screen, right? The kit. You were able to see that, right? Hello?
Yes, sir. We can see, sir.
And then we have an Arduino board, and then we have a different sensors here. We have a temperature, humidity, gas sensor, proximity sensor. Then we have light sensor. Then we have a moisture sensor here, and then we have motor control. Then you have some switches and LEDs. Everything we put together in this IoT kit, and then you power supply, and then there is a display here, which is LCD display here and 7-segment display. So you can connect all the sensors to this. You can choose whether you want to choose a Raspberry Pi board or an Arduino board, and you can choose it. And if you want to choose this, you can remove this and connect your wires, and then connect all the sensors and upload the data to the cloud. So this is all. Now let us see how we can include the blockchain. This one is a very experimental. All the academics, all the faculty, they use it for teaching IoT. It's becoming a very prime development kit, because what happened is, student, you just tell them to buy this Raspberry Pi board and a sensor and a connect in different way, right? So instead of that, everything is put together. Everything is on a PCB here, right? So this comes in a box here, like some of you might have studied in IoT. The microcontroller, right? We used to have 8086 microprocessor development board, right, in the colleges, or Z80, of course, old timer. So something like that. We have developed this, and you can use this board, and it has got a USB ports for connecting the external monitor and all this. So now And then the second version is also we have is this one. This is another IoT, the kit, the first version of the IoT kit. Now, let's see how we can make demonstration on these things. So it has got the gas sensor, light sensor, then we have got the air quality. This is our first version, which we developed as a part of teaching in Santa Clara University. Then it became a this thing. So here inside, sorry, there are a lot of octopus wires here, but you can see that there is a Marvel board, and there is a Marvel is nothing but an Intel, the ARM enabled board, and then we have some connectors where you can connect all the sensors to that. So now let's see how we can take your IoT journey to that, right? So let me keep it aside here and switch off the video and come back here. So let me see if any questions are there here. Any questions so far?
Sir, do we have available these kind of kits anywhere in through Amazon, Flipkart, and any e-commerce platform?
Yes, we implemented it in Amazon Web Services. The question is that whether you connected to the Amazon Web Services, right? I'm
talking about the hardware availability for us.
Yes, hardware availability is there. You can go to JUM portal. JUM is also there. There's government e-marketing, in India. And I think we installed about 25 at IIIT Kurnool, then another 100 plus in various regional colleges. Now we are talking to some NIT. So we put it on it's a government approved product, the JUM portal. No, it is available on the JUM portal. Does it answer your question, sir?
Yes, sir. Thank you.
Yeah.
Hello, sir.
So you can use that Tinker card for the FDP, but only problem with the Tinker card is we don't have access to the cloud, right?
Hello, sir. Dr. Mahdi, sir.
Say again.
Hello, sir.
Yes.
Hello.
Yes,
sir,
go ahead,
Pawan Kumar.
Good morning, sir.
Good morning, yeah.
Sir, I have one doubt. In Tinkercad, there is no Raspberry. Some few sensors is not there.
Yes, it's only Arduino board is there. That's right. Yes.
All Arduino, but not support to Raspberry Pi.
Correct. Yeah.
Sir, why you go for Raspberry Pi? Is there any particular that kind of site?
No, I don't think Raspberry Pi, because you remember that Raspberry Pi is a little complicated one because it has got its own operating system, it has got its own IOs, and it has got its own inside that flash memory. The Arduino board is good actually. They don't have any operating system, right? It's a real-time operating system. You connect to the PC and then you write the software on the PC, right? That's easy, So that's why Raspberry is difficult. Raspberry by itself is a computer, right? Yeah.
Yes, sir. Yes, sir. Thank you, sir. Thank you so much, sir.
Yeah. So with the help of blockchain and IoT, which type of application? Yeah, we have implemented for food industry, implemented for smart city, but I wouldn't say it's a complete blockchain implementation there. The blockchain requires huge memory and huge processing power, right? This at the most, this Raspberry Pi board, what I have on the board, it's and now I'm getting a 32 GB memory. 32 GB memory is also not sufficient, and because the Raspbian OS also takes some space, some sensors also take, all those things, right? Yeah. So application, there is one question. API is for user for application things. Yeah, the API is for a user. It is some kind of an you can integrate with the API for securely connected. That is basically a unique API for that. Yeah, I can show one ThinkSpeak example. So is the question that you want to connect it to the IoT hardware and show it? Is that a question? Yeah, okay. So what I will do, let me run through that. The whole title is blockchain. Maybe if you are there in the second half, I will try to show it. Basically there are a lot of slides are there. I have to connect it to the monitor. Maybe during the break, I need to connect to the monitor, and I will try to show that. I'll just make it a note down. Is it okay? Dr. Bhavya, I think there is some little this thing deviation on the IoT side. Is it okay? We can show that demo in the second half. Just how can we explore the hardware in FDP? FDP, in fact, what we can do, no, we are doing a virtual IoT course. What you can do. We have these hardware boxes with several places. In Santa Clara University, I have one in Northeast, one in our Bangalore, one. So we, as we speak, one of my colleagues, they're doing a remote. Everybody can log into this one through an VNC network. You can do that on virtual. If you're interested, we can talk about it and how we can do the virtual IoT lab on this. Okay, so let me integrate IoT with our computer system. So IoT, you cannot integrate IoT directly with the computer systems unless you have a simulator tool, sir. So we can have the simulator tool we can do, and we can try to get it onto the simulator tool. So, but best way is that I would say that because all this IoT, real time, it has to be sense the real time. The sensor, whatever I show, is all really time. It is connecting to all the boards and aspects together. Yeah, there's one. I don't know, sir, your name, user 143 says we're in virtual IoT lab. Yeah, if you're interested, let me give the contacts at the end of the course. Then we can talk about it. Okay. So that's good. Okay. Hope this is helping you all. Let me know if I'm going a little speed, or I can reduce a little bit of my pace here. Sir, do we store all data generated IoT by blockchain or do edge computing? Yeah, we can store. It's actually hybrid model there, so you can have that. Yeah. All right. So now let's move on to the next topic there. Okay. Yeah. So MQTT is another IoT protocol. It's a full IoT stuff like your HTTP protocol. It is basically it's a message queuing teleport transport. So that is another. Yeah, somebody has put it, message queue telemetry transport. Thank you. So that's the okay. So let me go on to the next slide of this. Is it okay, Professor Bhavya? We'll go ahead. We'll continue, right? All right. So then we have. Let me pull out my slide here. So this is how we have done it. It's an IoT development kit, as I showed you. We just put the temperature and the magnetic switch. This is used for an automobile industry. Actually, goal is to measure the temperature from that bearing and then send the data and then in a secured way, right? So let me show. So this is how the blockchain implementation on IoT devices. Again, I'm not fully convinced, but goal is because university or academic or research level, what do you get? You get only this limited resource, right? I cannot get a GPU or a CPU there, but at least goal is to get it. So on this kit, we got an Ethereum downloaded from this GitHub link. So there is a GitHub link. You get Ethereum uploaded here, and then all
screen
these.
Screen is not visible.
Sir, screen is not visible, sir.
Sorry about that. Okay. Is that okay, sir, now?
Yes, sir, it's okay, sir.
Okay. So I'm sorry about it. So previous block you might have not seen here. So this is the block which I have was showing. Thank you. Please do remind me, if you're not able to see the screen or if you're not able to hear me. Okay. So this is the is okay now, right?
Yes, sir, it's okay, sir.
Okay. So this is the Ethereum, and then we put that, and then we have a Linux Ubuntu. I put a Linux Ubuntu here. It is actually very complex process. That is why my colleague could not join. I told him that idea is I want to show them some lab. So this is he's still trying to get that up and running for this demo. So Ethereum, and then you put the Ethereum here, and these are the the sensors so we have on the board here. As you can see, I put the block 1, block 2, block 3. Technically speaking, it cannot be a so many block, but I'm just created an regional blockchain experiment here. No, I can just make it a block 1, block 6, and then this is how we step inward. So we have a GitHub link. If you are familiar with the GitHub link, you can go there and then see this. You get all these informations, setting the blockchain, then follow this process. First is to get the Ethereum on this. Before that, you download the Linux Ubuntu, start the node, and then then setting up the blockchain network, run the service, and start the blockchain. I think our colleague got stuck in the network, and hopefully he'll have the blockchain services on the node here, right? Yeah. So this is the another schematic diagram, basically implementing all those sensors here: light sensor, soil moisture, gas temperature, buzzer, and a flame sensor for different applications. Actually, this one we done for a food industry. Yesterday, I was giving a talk on FDP on the NIT at the NIT Nagaland, NIT it was. So it was basically they wanted the blockchain in the food industry. In fact, I recommended a topic, they approved that. So we demonstrated yesterday that all these sensor connected to this IoT development kit, and then we got the software, the blockchain software, and then connected through that. So now that is about the blockchain. How we can implement those things. So let's see some use cases here, right? So one is the food industry. See, food industry has got several chain, right? You have an input, then you have a productions, then processing, marketing, and consumers, right? Everything is there. Now how we can implement in the blockchain, So we have got a working demo. Those who are interested, later on we can discuss because we have a very limited time, but definitely I can share the working programmer. So this is your input in the farmers. This is in the productions, and then the processing and the marketing and the consumers, right? So you can include all these blocks here: block 1, block 2, and block 3, right? Right. So you can include the different blocks here. So here you can get your transaction initiated and then come onto this one. Yeah, this is another project for which we call it as a smart environmental monitoring as a part of Global City Team Challenge in US. We have implemented this project. So what we have done is Global City Team Challenge is nothing but it's hosted by National Institute of Software Technologies under the Department of Commerce. So myself and 3 other professors were a part of that committee. So we developed an environmental monitoring, right? Monitoring the light, gas, temperature, and air quality. We monitor that, and then you get the readings on this. This is an IoT, certain extent done the machine learning on this box, but not done the blockchain. Our next goal is to put this blockchain onto this and then try to evaluate whether it works for the blockchain here, right? So then Xtrans, where I'm one of the founder for that, we developed a cloud also, like ThinkSpeak. It's not a great cloud, but at least for university purpose or anything purpose you want to use it, it's free, right? It's available. We have the Xtrans cloud also, and then we have environmental and the data analytics here. Whatever, once you get to the cloud, you can connect it to the mobile phone, or you can connect it to your desktop, or you can connect to your gear, right? Wearable watch, right? So this is one project which you want to do that. This is another one which is a smart waste management system. Basically what it does is, this one is for city of San Leandro in California again. What they wanted, it actually started with the Cal Poly, which is a part of Cal Poly is in San Luis Obispo. They wanted to start a project from the student group that whenever there is a trash is full in the downtown or in the hilly area, they should get a message. The reason why they wanted to get it done is that all the trash collection or waste collections from this or the city or from the public, it's actually outsourced. Most of them they're outsourced. So they want to control the cost on that, So they said, okay, now we are spending too much, money on outsourcing this, but we want to control that, because this truck driver, whoever is collecting the trash, they goes whether trash is there or not, they keep on going there. So that's why they said, let's keep a track of how much trash we are sending and how much is this thing. So that's the the goal. Then what we have done is we just put a sensor on the top of it, as you can see here. So here there is a sensor here, the electronic sensor. So you monitor the the distance or the height of this trash, and then collect the data. Actually, you can select that 86% or 95%. You can define that in your Python coding, right? You say that, okay, my trash is about 85%, 180 centimeters suppose. So then it send the message, and then truck driver will send us some kind of a text message to the cloud, and then they can send the truck here, right? We integrated with that Twilio, but now most of this provider, for example, this ThinkSpeak, AWS, everybody is providing that, right? This is the smart street lighting. This is one project which we've done a proof of concept, where these are the street lights. You remember I showed our IoT development kit. There is a LEDs are there. These are the 4 LEDs. Okay, so 1, 2, 3. So these are the 4 LEDs, which actually I can light these LEDs depending upon the conditions, right? If only one person is going, I don't need all 3 street lights, right? I just need one light, right? If there is a one person and another person or a car is going, then you can light the second light here, right? So like that you can program it. All 4 you can program, all 3 you can program, all 2 you can program, right? It's a simple Python programming. I think if you know about the Python programming, you'll love it. It's really very good project there. So Raspberry Pi, it works. That's good. Those who are interested, we can attend. It's a 2-week of full complete end-to-end course there. Then it's a cloud, and then control and configuration, and then data analysis, right? So here also we want to implement a blockchain here. And so how we do, again here same Ethereum, you get the Ethereum software on this IoT box, right? Yeah, so this IoT box, and then connect. I will ask our colleagues to write some kind of an algorithm here software, so it connect to this box through this LoRa, and then it connects them. So hopefully we should have that implementation plan soon. This is again another supply chain logistics. So here, we have we have not implemented this, but I'm just showing some example how IoT continuously supply chain management, right? So how it tracks and how it monitor and how it analytics, right? So see here, all the devices are there here. In fact, one more example I may like to show here is that we did it one for NIT Bhopal. That is more of an smart meter. They want to show some kind of an working model for the smart meter, connecting the smart meters or a smart your electricity and the gas connections to the portal. So we showed that. That is also an IoT there. So there they use the Wi-Fi, your LoRa, or they can use the Bluetooth. So this is another one. So this is IoT. So blockchain can be implemented on the supply chain. I'm saying that. And then automotive industry, you can really do many things blockchain. So that will help for the owners, then for the transporters, for the warehouse where you keep it, and then the manufacturers. Then you have what authorized service center. Everybody helps. The idea here is whenever I take the car to some mechanic or repair authorized service center, they will tell you that this is a genuine car. Yes, this is in the network, in our network, and it's blockchain compliant. So let's approve that. Similarly for insurance, God forbidden, there should not be any accident. But if there is an accident, he or she goes to the insurance. Then insurance can check that this car is a blockchain network or non-blockchain network. They can really go through those stuff in that automotive industry. Then smart vehicle monitoring, we have done this using our IoT box actually, but here we put like I was telling, a temperature sensor which monitor the temperature of this bearing, and that temperature bearing record goes in all the level, and one can see that, okay, fine, this temperature is giving it. Okay, fine, I have got this hash for that particular car. I can monitor that aspects of that. Yeah. So this is the evaluation of blockchain, blockchain 1, blockchain 2, and the blockchain 3. So currently we are in blockchain 2 to 3, completely not 3.1. So blockchain 1 was just a introduced by paper, and then Bitcoin came. Now this Ethereum has come. So now we are into this stage, and then of course smart contract, those aspects are there. So with that, I think I can stop here. Somebody was asking for the break, but I have a few minutes to take any question and answer. And let me see if I can show some the ThinkSpeak demo, right? We'll see that, but let me take questions, so then we can come back. Then we can start on them. I'll keep the demo ready here. So then I have certain all the backup materials I can share. I don't want to just take that. So idea here is that how we can implement a blockchain into an IoT connected devices. And it is coming up actually. It's so much of a thing happening. It's basically most of we thought blockchain is only meant for Bitcoin. No, it's not so. It's coming up everywhere. Last week I had requested one of my colleague from Ericsson to give a talk. Ericsson in Santa Clara. So he was saying that even the connectivity side, 5G, you take this LoRa, 3G, 4G, and then your Bluetooth, everywhere they are talking about the blockchain. Now we want to make it sure that these are all connected through that one. So I didn't know that. I myself learned that there. Okay.
Sir, in chat box there are some questions, sir.
Okay, sure. I'll try to answer them. Okay.
Okay,
So let me close this. So let me stop us. Okay. So let me just open up here. All right, sir. So IoT is, let me take questions from the beginning where I left here. Okay. Okay. Using the board, we need to do some experiment. How can we connect all with the jump wires only for something? Yeah, we can connect the jump wires. We can connect those sensors through a wire. You can connect, if I answer correctly there, you can connect whatever sensors you want to do that. LoRa is a low range. Yes, it is a low range kind of in communications. We are doing it. It's actually, the data sheet says 50 miles, but it does. For an enterprise, you can do the fog computing. Why the name fog came? Fog is very closer to the earth. The cloud is little far away. That's why the fog computing came. And then what else? The question here is, can we please tell simulator for IoT blockchain implementation? So we don't have any simulator. I have not come across. Maybe it's so much technology, I have not come across. I'm sorry. IoT is implemented private or public block. It actually, you can, yeah, it is implemented most. It's a very good question. So IoT is implemented both in private and public. If private, if it is an enterprise, then you can implement only the private. Public, if you go to the smart city, it has to be public, and it cannot be private. Smart city or anything you're working with us, at least in US, what I've seen is any smart city data, it has to be public. Certain few datas are not public. Suppose some court cases are going on, some confidential information is there. Those things cannot be public. But in general, for example, my house here in San Jose, if you put that address, you'll see all the details of that particular house. When we bought, what is the tax structure, everything you can see that. So what are the electronic courses we have? So actually it's a one big course, 5-day course or a 10-day course, but it's a complete, we can go to semester, you can go to, what you call the quarterly, or you can go 5 days also. Tinkercad is ritual. I'm asking building a real-time systems. Yeah, actually, I have only little experience on the Tinkercad because I'm a strong believer in doing it on the hardware, on the real time, right? I mean, if you do Tinkercad, what do you do? I mean, you want to build a script for the fog environment, but if you're interested, I can give my contacts. I can share some, link on that. All right, so I think I have answered whatever I can do it from here. So with that, probably we will, in smart monitoring, are you predict environmental like? Yes, we are predicting the air quality, predicting that when I say temperature, then so then we have the air quality, temperature, everything we can do in the environment. You see, this Raspberry Pi good thing is about 20 plus ports are there. No, in Arduino we have a limited port, analog port, and digital port. Here we got several ports. As long as you know how to interface with that, you are good in that, right? So with that, I think I will, I know some of you want to take a break. Even I also need to take some break and come back. Yes, Professor Bhavya, what time we should be meeting there?
Sir, so the next session will start at 12 o'clock, sir.
12 o'clock. Okay, here it is for me 11:30. That means half an hour from now, right? Yeah.
Yes, sir. Yes, sir.
Half an hour. Okay, sure. I will be available 12 noon. Okay.
Okay, sir. Dear participants,
okay. Thank you.
There will be a break for half an hour. Again, come back at 12 o'clock. Stay in the same session. Please, all of us stay in the same session. Thank you all.
So, Professor Bhavya, can I talk? Can I keep on this? Just keep the video and audio off here. Is it okay, or you want me to log in again?
Yes, sir. Is it okay, sir? Is it okay, sir? Please switch off audio and video, sir. It's okay, sir. Okay, sir.
Thank you all. See you soon.
Dear participants, there will be a break up to 12 o'clock. Please stay in the same session. Thank you.
All right, so I'm back here. Yes, Professor Bhavya, I'm back here. I'm ready here. Can we start?
Yeah, yes, sir. Yes, sir. Kumar, sir.
Okay, good. Okay, good. We can start that. Okay, it's
Please,
almost
yeah,
12
please
p.m.
carry on, sir. Please carry on.
Okay. Okay, thank you. Thank you so much. Okay.
Right,
All right.
right.
So, good afternoon, everyone. Hope you had a good break, small break, back here. So, my next session is going to be on the Bitcoin. I was trying to set up my hardware here. I will see if I can still show it. Otherwise, I can log into ThinkSpeak again, like last time I did, and show how we can, do that. And I also have my colleague joining. Hopefully, he joined. I don't see in his name. Is Krishan? Are you logged in? So he's getting logged in there. Let me see if he's logged in there. I don't know. Christian has got an ability to speak when he's logged in there. So he's trying to log in there. Anyway, he'll get logged in there. So let me. So okay, let's start without further ado. Let's take. He would be joining. In case if he's got difficulty, I may have to just sync up with him. Okay. Other than that, let's start the next course here. Is that so we talk about the Bitcoin right now. Okay.
Sir, screen it not visible, sir.
Yeah, I'm showing it. Sorry. All right. So let me get back to here.
Still
Yes,
screen is not visible, sir.
Can you see my screen there, please?
No, sir. No, sir.
No.
No, sir.
Now is it stable?
No, sir.
Oh, I'm sorry. Okay. This Microsoft is sometimes. Now you're able to see that?
Now it is okay, sir.
Okay. Thank you. Yeah. All right. All right. So let's see what the Bitcoin, what they talk about the Bitcoin. I will run through some theory aspects, and then we have two demos. We'll try to demonstrate the two demo. One implementation on Raspberry Pi. I was just taking a stock from my colleague Krishan. So somehow he said that still he is unable to get complete running, but at least he can show it on a Raspberry Pi and some kind of an desktop versions. He has got it. So let's talk about the Bitcoin a little bit here. What the Bitcoin is that actually I just put my perspective there based on my research and my study. It's everything talks about revolve around the money, right? It's money, which is it could be a dollar, euro, rupees, whatever currency you have got money, which is the value, when I say value, it could be your any goods, gold items, or it could be any, any of your materials from online what you buy, anything valuated, right? It could be your house or it could be a car. Anything is a value, right? Money which equate to value, that is equal to a trust, right? I mean, that's how the whole concept, right? You have the money, then we need to have the trust. You have the trust in the bank, right? Nowadays we have is that we go to the bank and we have the Visa, trust has been built there, and it's everything is happening on the paper money, right? We have a everything whatever we deal, it's a paper money, right? So we print based on the the economist what they plan every quarter, every year. I'm not an expert in economist, but there is a formula to print this much of money based on your the productions are based on your productivity, right? Company productivity. So and then we everything we deal through the banks. We have the bills and notes, we call it the dollar bills, and we have the rupees notes, right? We call it the notes or rupees. So here it is dollar bills, right? So then currently we have a kind of in fiat money, that means it's produced, it's actually circulating from the government, central bank, and to us consumers, or consumers to the bank, or to the all the goods what you buy. And it is all centralized bank, right? To give everything, and it is all controlled by the government. Most of the country, it is all, everything is controlled by the government. I don't see any private organizations controlling the your money, right? Money is nobody's printing in the privately, right? Everything is printed by the government there. So what is the challenges we have? What are the, why we cannot use the same model? Why this the author recommended that we'll have a some kind of an alternative method to that. What are the good challenges in this? One is a mismanagement, right? This when you have the currency, it is a mismanagement. Lot of mismanagement things is happening, right? It happened all over the places, not only here. So even government, they have a challenge to manage that so much of it's a gigantic mission, right? Anything mismanagement can happen. Mismanagement is that you might have read that Wells Fargo Bank, in the US, one of the renowned Wells Fargo Bank, they see 1.4 million accounts created by their own employees. It's inside their own employees, just to manipulate or just to change the accounting inside. 1.4 million, they identified that 1.4 million people have identified, have reference. And one of the country, I forgot that, they have produced more currency than what is needed, right? And the importance has gone there. If you produce more money, and then people, when they start exchanging that, the value will come down, right? And more money, I was reading an article, they have generated so much of money. And in India also it happened, right? They had to ban this 500 and 1000 rupees, right? It happened a couple of years back, that because because of the what you call that, there were a lot of duplications were coming up, lot of malpractice happening up, so they had to ban those things and come back to the business, right? So those are the examples why the current model will not work now, right? Because they have to dismantle everything and do it. And then losing the control on the consumers. As a consumers, you and I, we are losing that control. We don't know what is happening in the centralized, right? Everything is going through the centralized one. And then corruptions, some of the countries, some of the states, some of the, when I say states, is a corruption. So we don't know what it happened when the money goes to the central bank and then to the government. We really don't know what is the distance. And devaluation is happens to your currency. Then purchase power, whatever you want to do, the purchase power, it always depends. Actually, as a common man, you and me may not be able to identify what is that purchase power. But if you really look into a microeconomics theory, again, I'm not an economic specialist. So there, you have purchase power definitely has come down. So that's what. So these are the challenges with the current model. That's why the author came out with a new substitutions alternative method there, right? Yeah. So what is the suggested alternative model? So what are the model that Satoshi Nakamoto, what he suggested through paper? See, this what it happens, he published a paper and it become very, very popular these days, right? We never know. That's why I keep telling my research students, right? You think about the paper, we never know what that publications will become, right? So this is a very classic example that his paper, he just introduced in 2008 in a very humble way, in a very simple way. And his paper also, I got a copy of his paper, what he published, So many of you have seen that. So in a very simple way, he showed it. I'll show that paper. I think I should have that. And he says that is, transparent. It has to be transparent, like I discussed in the first session. Everybody should be able to see from one other the one. So then it has to be, decentralized. It's gone are those days that you keep everything controlled and then decentralized. And control over the double spending money. Right? That's in other ways that one note is corresponds to equal to only one note. No? We don't want to have a duplicate or a repetition of the double spending money, what they call double spending money for that particular commodity. Right? I have $1 or 1 rupee or 100 rupees. Then I should spend only one time. I don't want to spend again that, because somebody can really print that note and I can have a double spending money, right? And copy of ledgers, we keep all the transactions in the ledgers. Right? Whatever is happening, we'll keep in the ledgers. And since it's a digital currency, we'll have a computer power, right? Thousands of computer power, you will see it in the whole scenario over there. So it's one example, I would say is that it's like a newspaper, right? I mean, many of you might have seen that before that, all the news, all the content, we used to depend only on the newspaper, right? We used to get whatever local newspaper, like Deccan Chronicle or Deccan Herald or Times of India, right? When I was there, I used to follow the Times of India or the Deccan Herald in Bangalore. So we get the news only from the news agent, right? But now that whole thing is changed, right? It's like an internet news, right? You don't need a newspaper. I don't know how many people really ordering. I stopped getting my newspaper here. Everything is on the internet now. It's a same concept here. Everything it used to come from the press or the news from the publications. Now that has been replaced with the internet news. Is exactly you replicate that for the Bitcoin. Everything it used to come from the central bank or from the government, the notes. Now we are replacing through the internet currency or the digital currency, right? In a very, very sophisticated, right? So what are the advantages we have here? So 1 second, my colleague may be calling. I'm sorry about that. I'm sorry about that. I'll let you just. Hello. Yeah. Oh, they have to allow you? Oh, okay, 1 second. Let me ask you. Professor Bhavya, is it the login, whatever you gave? I think my login only. I'm sorry, audience. It's some kind of.
Yes, sir. Yes, sir.
So is the same thing? But he's saying that he's waiting for that.
Yes, sir. Yes, sir. Otherwise, sir can log in with. Sir, I have given another guest ID, sir, for you.
Oh, guest ID. Okay. Oh, okay. So he's logging in whatever ID, but let me see. Yeah, Kishan, I'm giving you one more login. Can you log into that, please? I'm sending it to you. Sorry about that. Okay, sure. So the guest 8, something like that. Yeah, Professor Bhavya, he says guest 8 only he's not able to log in, So guest 8 I have given him.
Yes, sir. Guest 8, sir.
He's not able to log in. He says that he's waiting for the guest to allow him or something.
Otherwise, sir can stay in resource 1 only, sir.
In my login?
Yes, sir. Yes, sir.
Oh, okay. 1 second here. Okay. So I'll give it to him here again. Sorry. So he can log in from the guest state is not happening. So he can use this resource, right?
Yes, sir. Yes, sir.
Um, yeah, so he will log in there. Okay, probably he log in through the instance of that resource one. Okay, yeah.
Yes, sir. Yes, sir.
Okay, all right. Sorry about that. So. Okay, so already I'm sharing my screen here. I don't have to share again here. You're able to see my screen, right? Yeah.
Yes, sir.
Okay. So here, so it's we talked about the thousands of computer power. It's GPU is coming up, and we talked about the paper, and then we go on to the. So it's fully controlled. When you have this, Bitcoin, you are controlled by this one and no middleman. That means there is no bank, there is no government. Straight away you are there, face to face, right? And it is a programmable. That is a good thing, right? You can program it and you can connect as Bitcoins as possible and open to all. It's not that okay, no, you have to have minimum deposit of this much, minimum of this much. Of course, now in India, the banks are quite open there. Anybody can go there with a zero rupee account also. So, but in US, if you want to maintain account, we need to have certain balance, So it's not open to all, and then they go through all the process, your social security, then your, background check, everything, and then only they'll create, and somebody has to approve them. Okay, now he's a eligible account holder. Everything is controlled by the bank as per the federal government, right? Yeah. So now let's go on to the crypto currency. That's a part of your Bitcoin, what it is. So I just very quickly do that. Digital currency of digital money is an internet-based medium, like I explained earlier, distinct from the physical, that exhibit properties similar to physical currencies. So then you have the, a digital currency in which encryption techniques are used to regulate generation of units or the currency. So they use it for the generic purpose there. And first Bitcoin back in 2009 when the author published this paper. And today there are hundreds of other cryptocurrencies often referred to as ALT coins here. Okay, what is the cryptocurrency itself? With the public record, cryptocurrencies do not require you trust a bank to hold your money. Like we talked about, right? There's no bank or any other trusted person there. You can always, as long as the network node we talked about, right? The blockchain network, activate, you are fine with that, So you can actually see the money being sent, received, verified, and recorded by thousands of people. This system requires no trust at all, and this is solid verification method. It's not just like I showed an example, send encryption and decryption. It's actually hard code entered into the CPU. That's why whenever you want to, the miner need to have a high power of computing power, because they need to have the resources to compute that kind of systems on there. Now, then this is a little bit about history of the cryptocurrency, when it started, and what stage we are in. So it actually started, they say, 98, and then it went through, Santoshi, the Nakamoto has Santosh has write the white paper detailing the coin, and then Bitcoin is released, and the first 50 Bitcoins are mined by Nakamoto, and then he himself is mined, in his PC. I mean, it's very interesting technology. It's complex, but very interesting. You know, his thoughts. I must admire his thoughts. You know, how he really thought about it. And of course, based on the experience. You know, he thought that okay, this currency has to change to a digital currency, right? The first ever purchase using the bitcoins occurs, and then then it went up. So today, you know, it passes 19,000. It's up to 2018. We have the statistics. We don't know what is there in the 2019. And again, cryptocurrency, opened several doors, several opportunities, several components, several benefits for the economics, especially when you go for the microeconomics. Then it actually generated the Bitcoin, Ethereum, then dedicated hardware. So hardware is also manufactured based on the cryptocurrency over there, and legality, of course, tax and fraud, everything we are able to detect from there. So this is how it works basically. Like we talked about it, right? 6 steps or 7 steps last time we talked about it, but this is a more detailed picture about that and how it works. Someone requests a transaction here, and then it's so someone requests a transaction here, and then requested transaction is broadcast to a peer-to-peer way, and then it's validating it here. Once it is verified, I'm just moving my cursor. Once it is verified, it's basically combined with the other transaction. They basically everybody is verified in the node here. The new block is then added to the existing blockchain, and then the transaction is complete. You remember we talked about this, right? So then we have in parallel to that, there's a cryptocurrency exchange going on here, and then we have has no intrinsic here. That is true. Has no physical form, and there's no physical form, right? Everything is happening by digital. That's why it's a Bitcoin. No, bit is that your digital bit, and a coin is a coin, right? It's not any and this is a Bitcoin is a Bitcoin, right? We don't use a different currency over there. So that's about that. And 5 kinds of perspectives are there. So you have a new team adding to that. Designers, you can design it. I mean, those who wants to develop their career, these are the different opportunities you got. You also know you can have like a Bitcoin exchange, right? You can create that exchange, create your own community, and this one. There's a mixed responses coming from the different countries. I have skipped those slides or removed it. But idea here is our goal is to teach technology. We don't know the economics or the political side. That I don't want to cover up that. But this is the technology FD program, right? So then technology underlying digital currencies, and then you have a state machine replication. This is a very complex method. I'm also still learning. It's how complex algorithms is working on that. That's why our effort is to put it on this Raspberry Pi first, and then we move on to a higher project. If required, we can install high-end machine on this board. Then we can do the experimental on that. Hybrid consensus analysis of blockchain, and then distributed blackboard, and then the private data. Some of you asked that is a private data or a different. Definitely, you can make it as a private or make it as a public. So is again Bitcoin is based on distributed ledger. We talked about it. I think this is we're repeating that, but just want to make sure that you understand the distributed ledger, which is nothing but a peer-to-peer. That means each one has got accountable that what is happening in my previous block and where it is going then, right? So this is the complete definition of a Bitcoin. It's group of people in the name of Satoshi Nakamoto, and we talked about it because it does not rely on government or a bank. We talked about it already. So then we have how this the Bitcoin price index itself, and how it goes from July to May 2020. Just show the graph here, right? From how it is a trading. That's very glad to see that it's a trading happening, right? I mean, there are miners, they mine the Bitcoin, and then it's a very, I mean, I don't know how it is really very successful there. No, I mean, nobody thought that it's going to be such a successful model. So and very tightly controlled, and it's an open source, right? Yeah. This is some kind of a ledger, and then the structure of a Bitcoin, is we talked about in my first slide. So we have David to Sandra, then Lisa to Sandra, we're sending it, and then there is a different block ID here. So this is what the block ID or hash ID, right? Previous block ID, previous ID. So here we shown here, right? We remember that we talked about in the first this previous block ID. Here it goes, and then this previous ID goes in the next one to identify that. Yes, it's a very valid, right? I mean, if you know from and to, it's good. You trust, right? It's simple like a letter, right? Any mail, not the email. I'm saying that any letter comes, if somebody has written from and to you, you trust it. If somebody has not written any from, just write it here. There's no logo, nothing. Just write your address. You obviously say that no, this is who has sent this letter. This could be a fake or some advertisement. Somebody is trying to sell the product. You the trust level really goes into second or third. Still, you open up because you're curious, right? You need to know what is there inside the envelope, right? But if somebody has not written any from address, then you will the trust level has gone. So that's why idea here is from where it is coming and from where it is going. Of course, in the postal example, we may not be recording where it is going, but at least as a consumer, you will look into it. So this is the mechanism they shown. This is the node. We will show how our Raspberry Pi, will create as a node, because that's an academic platform. I would always call it as an open source academic platform. And then we have a Bitcoin network here. So then we communicate to this one here. Okay. And this is the block structure again. I would requested Kishan to take about the block when he's explaining the demo. Instead of I explain, it's a very complex. Even I am also in the learning phase that how this hash really, how I can derive the hash from the mining, right? I need to create some hash. I was trying to do it in the Raspberry Pi. I thought we'll do something, but he has come to a certain extent. So I want to keep that hunger to him. He will go through that. So this is what is the mining. Next subject is the mining. That is about the Bitcoin. We talked about it. Bitcoin is nothing but a digital currency. It's generated by the miner, and it's in the node. Everyone knows that what Bitcoins I have, what Bitcoins you wanted. So what is the Bitcoin in nutshell? So in nutshell, Bitcoin is, it's like gold mine, right? We call it as a gold mine, or this is in this case is a bit miner. Right? The miners bundle the transaction to create a block and start mining process to verify the transactions, right? You could be miner, but you just be prepared that you need to have an really high computational machines to that. And this is created based on this according to SHA 256 standards, right? They create those hash based on this 256, it's one kind of an encryption there. So here some examples shown here. Bob sent the money, then they have miners, then Alice receive the money. So they don't know what the miner is giving that, right? Bob creates a new transaction and broadcast a Bitcoin network. And then the miner will say that, okay, now I need to generate this thing for this Bob. It generates, and then she gets it, and the transaction is complete here. So this is how the Bitcoin transaction it works. It looks like some snake and ladder, chart, but it's complex, right? It goes from, input is that wallets and the addresses, and then creating a new address, then submitting payment. You see, this is exactly they followed the bank process, but only thing is everything is in the digital decentralized ledger. You think of any bank, how do you do that bank? You go to the bank. Of course, nowadays you are doing everything online or from the mobile phone. But earlier days, right? Few of you might have there that earlier used to go to the bank. Even some of the rural places, right? They don't have a internet. They still have this process, right? They go to the bank, then counter, and then it goes to the entry. Then they enter it daily at 5 o'clock. That whoever is a branch manager, associate, they enter in the ledger, and ledger means computer now. Then it goes to the central computer, or they report to the center that this much transaction happened, this much money removed, and this much. So similar fashion, it goes through that, but everything is happening digital, right? You don't have to go to any places here, verifying the transactions. So I'm going to share this screen with you, then you will have a lot of time on that. Okay. So now with that, I will leave it some time for the demo. So hopefully Kishan has joined. He is going to log into his system. So we have a good, I think, half an hour to give a demo. And meantime, I'll see if I can work. Otherwise, I will. Yeah, one more thing I promised, that the paper. I think you might have seen the paper. I just want to show that what the paper looks like. So what paper looks like here? Documents. Fine. Okay, so you can see my screen, right?
No,
Can you
sir.
see my screen?
No, sir.
No? Oh, I'm sorry. This Microsoft kills me with a Mac machine. They are not that much of friend here. Okay. Can you see that now?
Still no, sir.
No, sir. Still it is not visible, sir.
Not coming? Oh, come
No,
on,
sir.
Microsoft friends. Okay. His earlier screen was visible, right, when I was presenting, right?
Yes,
Yes,
sir.
yes,
It's
yes, sir.
visible, sir.
Sorry. Oh, yeah. Now it is taking it here. Now you can see that, right?
Yes, sir.
You can see my screen,
Yes, sir.
right?
It's visible, sir.
Okay. Sorry, my screen is a little bit of messy. I want to clear it up my desktop. So many. So this is the white paper. I think you might have seen that, but just in case if you've not seen the Bitcoin peer-to-peer, this is how Satoshi Nakamoto, he has created that, and he clearly explains. See, very simple paper. No, is anyone thought that it's going to be such a big one? Whole revolution is changed that, right? So he talked about what is the introduction. He talked about the transactions. Owners one public, then your transactions. How we can create the public key. He just named it as a public key. Then later, it came into hash or the new fingerprint technology were there. And then he talked about the timestamp server. He talked about timestamp server and what is the proof of work. So then he also talked about the network, what kind of to run the network, whatever the steps involved into the network. And then he talked about the incentive. What is the incentive? We already covered up there. So he also talked about, in the last paragraph, if a greedy attacker is able to assemble more CPU power than all honest nodes, he would have to choose between using it as a defraud people by stealing back his payments. So that's what, I cannot assemble a computer, for everybody, some hundreds or thousands of systems, right? So then reclaiming disk space. Then he talked about the simplified payment verifications, how we can do the verification. He's talking about that. Then he's also talking about the combining and splitting the value. Then privacy. I can share this if you like. If you can Google around. This paper is available on the website, but if you like, I can share that. So these are some references what is shown, right? So you see, he's taken the 1957 references, one introduction to probability theory and its applications. Wow, you see, we studied, in the second year communication, right? Probability theory. So he took taken that reference number 8, So he studied that, computer society. Then I'm also looking along with you. I didn't see those references. Okay. So yeah, with that. I will stop here and I will hand it over to Kishan. Okay. Stop here. Okay.
Okay, sir. Thank you.
Okay,
Hello,
Kishan.
everyone.
Okay, go ahead.
Yeah, so already you understand about cryptocurrency, Bitcoin, and all those things. So now here is the part is the visual demo, because again I understand that is a visualization is very difficult how actually internally is working, like transaction of the Bitcoins and internal what mechanism they are using, what is the hash, how hash is generating, and few participants also asking about that, what is the nonce, once nonce is generating at the same time, then why hash is not to be same or something like that. There are many questions. Okay, so I will try to wrap up all those questions during this demo. So I hope this demo will like it so much. So let's start without any delay. So I'm trying to share my screen first. So I hope okay, now it's a visual for you guys. It's a visual for you.
Yes, yes, sir.
Yes, sir, it is visible, sir.
Okay, great. So now let's start with the first thing. So basically anything, if I'm talking about the Bitcoin, so there is a nothing but that is the information that is stored inside the block, right? We are storing some value like a 10 Bitcoin, 10. So there is a number obviously, then that is storing the value. Now like a 10 Bitcoin, I want to send some Bob to Elias, then what is happening? So 10 value I am sending to the Bob to Elias through the our public key. We are encrypted with the private key, and it will be decrypted with the public key. So that is the same similar fashion. So how is the data is, so basically the question is here, how block is generating, how, what is the block, what is the hash? So simple things I'm just trying to type here, just like hello Christian. So once you will see, once I'm typing something here, you can see there's a hash is generating, and that is the fixed length of the hash. Are you able to see that one? Every wordings, once I'm typing then and removing, then hash is generated randomly. So one participant asked, okay, hash should be the same. So firstly, my dear friend, hash will not be like, same hash will not generate. Every time it will be the random hash will be generating. If you are transacting anything, any values, anything, then even if the same thing you will do, then also hash will be generating. And how his hash is generating, who will do the first hash? So basically that is the comes on the picture, that is called miners. So miners, what is the role, what is the role of the miners? Actually miners is basically what he's doing. So once you are doing like I am Christian sending to the Rita 10 Bitcoin, okay, I send it out. Okay, something like a Ram is sending to the Sham 20 Bitcoin. That is comes, all the transactions is comes under the pool. That is you can say you can give the name, that is called transaction pool. So in the transactions pool, once all money will go inside, then miners what he's doing, he's doing the all transactions, he's keeping the record in the, that is called actually Merkle tree. So all the transactions is comes in the sequence of the Merkle tree, and after that who miners did the first generating the block, and that is like a type of a race, right? So who like a miner is did the first block generated, then he will do like a hand up, yes I did, and after that that block will be connected with the earlier block, actually whatever the block is created. So same hash it will be generated, new hash will be generated, and that is the linked with the previous hash. How it's a linking to the previous hash? Just come in the here in the block. So just see here, there is a three things you have to know. That is the first is the block, second is the nonce, and third one is the data. Whatever the is, might be a data, can be your values, or might be your Bitcoin. Today's the topic is the cryptocurrency currency. So I will only talk about the currencies, values, something like a integer values. Okay. So once you will give the 10, so something you can see that is the wrong. So again the concept, new concept is coming. Why it's in basically no one can interrupt, like no one can change the value inside the blockchain. Why? See, this is the block. Right now it's okay, this is the green color, but if I'm trying to change some value here, then you have to mine again, and you have to add. So that is the auto generated mining. There is no internal miners are there, but here the visual concept you can get it actually how it can be happen. So once I'm doing the mining, it will take some time. That is called the mining processing time. Generally in the Bitcoin is taking around I think 7 to 10 transactions per minute, something like that is there. and Ethereum is also one of the cryptocurrency that is much more faster than the Bitcoin. So today is topic on the Bitcoin. So only I will try to relate with the others, but my main focus will be on the Bitcoin only. So you can see that now this value is mined by the miners, like internally is mined by the miners, you can say, and that is a hash is generating. And always remember in the Bitcoin that is hash is basically started with the 4050, sorry. Yeah, here is a 40 is generating. So few zeros is starting with the minus, and that is the basically hash is generated. Suppose I am a hacker and I am trying to change the value here. So what I can do, I can just do the 15. Then see you can what is happening. Hash is damaged, like is discarded the earlier hash, and after that is generating the new hash. Again you have to mine. Then and miner obviously he will deny because you can't send the 15 BTC. You only send the 10 BTC and you don't have a 15 Bitcoin, then he will deny. And how it will record will be tracked. Suppose I am a person, then I have suppose 10 Bitcoin. So 10 Bitcoin, definitely 10 Bitcoin is not coming in the air. Someone will send, then definitely I will get the 10 Bitcoin, correct? So once I will purchase anything, like someone sent, like a Rita sent to Kishan, right? Then 5 Bitcoin, then I have only 5 Bitcoin. There is no back track record with a 10 Bitcoin. That means if I am showing that I have a 10 Bitcoin, that is the wrong data, correct? So something like that is a traceable. So that is the concept is coming tracing. So blockchain basically is a give you the allow to trace any person. So that's and all the things is happened in the blockchain. That's why it is like a trustable and anyone can trust over the things, because the encryption algorithm and all the things is very tough to decrypt it. Obviously in the classical computer that is very difficult to crack that one. It might be in the future if a quantum computer or something it's can become, then might be it will be. So that time we can also give the such type of solution, like again new algorithm is coming, like a post quantum cryptography and other types of cryptography is coming. So might be those cryptographic algorithms can be defend our blockchain system. So that is the different thing, that is the future scope. Now I'm talking where we are existing. So this is the data and this is the hashing is generated here, okay? Now how it's a chain is generated, how hash is linked to the other link, that is the second visual demo. This is the basically our chain. Now you can see here there is a multiple blocks are created, and one person I remember that in the chat I seen, he is asking about that, sir, in the every node every block is the same, right? Correct. So that is the concept of the decentralized, if you and distributed basically. So what is the meaning of distributed? So same data, like whatever the transaction is happened, so in like a RAM to SAM, not only it will be happened in the RAM to SAM, it's the every peers that block will be added. So if you remember in the 2000 I think I did first downloaded the blockchain like a Bitcoin all nodes in the 2014 actually. Basically that time it's a 1.5 GB almost. Nowadays you can imagine how many blocks is added in the all over the world, right? So it's going to be I think more than the 2 TB or something like that. It's more than that actually, even can't. Okay, so that is the things, and every day it's actually nodes are increasing day by day, sorry, blocks are increasing day by day. So that is the thing. So that's why the concept again is coming that, because every system if you will download the all nodes, that is very difficult and system will become slow. So what is the solution for that? Because that is not feasible also. Okay, every nodes, if you want to become part of that network like a Bitcoin, then you have to download all the nodes. That is not a good idea. So what we have to do? So we have to download some Litecoins. That is the concept is called Bitcoin Lite. If you seen somewhere, so they will give to the option. You want to download Ethereum Lite, Bitcoin Lite, or Ethereum full node, or Bitcoin full node. So again, it's up to you. So which type of version you want to download. So that is the second thing. So basically how it's a link to each other I'm talking about, like how blockchain is generating. Suppose this is already all the things are green. If you are able to see, it's not a proper green, but I'm telling, okay, it's looks like a green. So I will tell green. So what is happening here? If I will change some value, right now there is no value. I'm just typing here 10 BTC. Okay, so here I'm just trying to mine. So once you will see, once you will mine will done, then entire block is going to be red. even you can't see the things. So that is the basically concept. Like if you will change inside the one block, entire block will be denied. Means you can't change at a moment, like in a particular block. Okay, suppose in block number 147, like a Krishan and Elisa have some transaction happened, and you want to change that particular block, then entire block will be discarded by the others. So that is the basically beautiful concept of the blockchain. So he will not accept, see, other are not accepted your transactions, whatever you are given 10 BTC or something like that. So these are all are denied to do that. So again, what you have to do, how it will be acceptable, again you have to mine one by one. Again you have to mine like this. Again every block you have to mine. So once you have to do some any corrupt transaction, then what you have to do, you have to mine that all over the block. That is not an easy task actually. That is a huge amount of electricity resource you required, and in the very few minutes, because already blocks are added on that particular network. So in that time you have to create your own network. That is really is not physically, it's not feasible. Okay, now I hope you understand the concept now. So what is the chaining? And so every time it will particular nonce is generating. So you can see once I will create something, then nonce will be different, like a 10 BTC coin extrans to something like something like that. Now I'm trying to, then again nonce will be random, it will be generated. Okay, so it will take time for the mining. Again it's depend on the sometimes internet speed. So basically nonce will generate. So see, now the nonce is the 74569. Okay, so this is random nonce is generating. So this is a similar way fashion. Once you will do the mining, again nonce will be generating the different way. So these are the all hash, and you can see that is the previous hash, and this is the hash of the block. So this previous hash, obviously this first block, that is called also the Genesis block. So Genesis block, basically the hash is 00000, because there is a no hash. This is a first hash value, and after that is linking to the each other. Now is a see whatever the hash value of the block 1, that is the work for the second block, that is called the previous hash. Again the third block, that is the connected with the. So similar fashion it is working. Now the concept blockchain you understand, block you understand. Now how it's distributed, how it's like a peer-to-peer, how the different nodes are synced up to each other. Now you can able to visualize here. So how it's working, like you see in the distributed block. So these are the distributed blockchain. So you can see that is the peer 1, peer A, peer B, peer C, and so on. So basically peer A and peer B, that is nothing but your own system. You can say that is my peer system, and peer B is the other node actually. So once you can see every peers have a same nonce value. If you are able to see that one, same nonce and the same data as well as, and you can see that is the same hash 15783, and sorry. Yeah, so here hash, obviously hash will be different, like a nonce value will be the same, but hash will be different, right? So you can see 15783 same, B764. So every hash you can see here in the first peer. So 15783B, and here is the one, this is the previous, and again this is the hash, and this is the connected to the others, something like that. Again same way, 15783B7, again here is the previous block, and all are the same peers in the every peers is the same block. You are able to see. If you do some changes here, like 10 Bitcoin, then it will be discarded by the others. You can see here. Okay, so once you did in the 10 Bitcoin, then what is happening? So it's in the every, like other peers, that is a no data, like only in the your peers it is changed, and again you have to do the whole data. So suppose I am the culprit, like if any person, like I am not an honest person, I want to do some changing in the my system, and I did the whole block, I did changes. But the thing is that if a peer A only do the change, it's not sync up with the others, because it should be mined, then only if a block will be added properly, then it will be add on the peer B, again then only it will be, so only valid transactions will be sync up with the others peers also as well as. Like if like a transactions will not acceptable, then it will not sync up with the other peers, and automatically peer B will say no, your whatever your transaction is that is not valid, that is invalid transactions. Correct? I hope you understand a little bit idea how it's working and how internal structure is working. Now I want to give the real tokens, how is the tokens is sending to the Elias to Bob and Bob to Elias, something like that. So now I'm going to the third part, that is called tokens. Okay, this link also I'm going to send you, so just you can go and plug and play. Just open this link and you can just try to play. Okay, in the last I will send that. Okay. A link also I am sending to you, so after the session also you can go through it and just try to understand. Okay, now that is the peer A and peer B, something like that. You can see that is the fully distributed and how the transactions is happened. So whatever the if you remember earlier I told every transactions is comes under the transactions pool. So basically all the transactions, suppose I am a miner, what I will do, if you will give me the transaction, so every transactions have some transactions fee and all those things. If you will give the more transactions fee, obviously I will be more interested to do your transactions, right? Because obviously if I will do the transactions, then I will got the rewards. That rewards is nothing but that is the Bitcoin, correct? So that's why I will give, suppose here you can see that is the Darcy to Bingley, again Elizabeth to Jen, and this is already predefined. So if you will do some changes here, then automatically it should be denied. See, all the value it will be denied. So same like that concept, that is the previous hash, this is the hash value, and all this is the transactions pool. And who is the miner? Miner has created the block actually. Okay. So up to now there is any questions, you can text me, so I will going to read these blocks are running in the different nodes under private network. No. So basically in the Bitcoin there is obviously there is a two concept, that is the private network, that is the public network, and one is the hybrid network, that is you can say that is the public and private. So that is the customized network also you can say. So basically Bitcoin, Ethereum and others, whatever the lithium coin, whatever you seen, right, these all are the public Bitcoin. Means what is the meaning of that public blockchain? What is the meaning of the public blockchain? Anyone can see the transactions of the currencies. So how can you see the transactions? There is a one Coinbase was there. Let me check is available or not. So here you can see the whole transactions and all people, whatever the values is coming. So just let me open this one. Okay, once you will log in, right, so you can see the all prices and all those things. So I don't have login test. Let me check. Oh, again that is the verification. Okay, it will take time. Okay, anyway, so this is the basically Coinbase. So basically what is happening, so once you want to see the any one transaction, so what you have to do, so once you will download the Bitcoin app, I will suggest if you will go after this demo and all those things, just download the Bitcoin app. That is the app is basically two things, that is called one public address and one is the private address. So basically private key, what is that? That is your secret key, basically don't share with that one. So basically it is required for recovering your wallet, like any Bitcoin wallet, right? And what is the public address? So that is the public address, nothing but you can post over the Bitcoin and you can see, okay, how many transactions happened in the public address. Like anyone can see the transaction. Obviously your name and all those things will not display, but the transactions history can be displayed there. So that is the beautiful thing. So anyone can see your the transactions details. Really you have that much Bitcoin or something like that. So that is the trust authorities coming, and no one can change your thing. Like generally people are very afraid to show the transactions and bank account statement, something like that. But that is the beautiful things of the Bitcoin currency. So anyone, we can share the anything within that. So this is the whole concept of peers and blocks. So you can see these are the I don't want to take too much time. Again, you can just go and plug in. I think inner concept you understand. And this is the Coinbase basically. One other thing. So this is the hash is generated and one hash other thing. This is almost the same thing. Okay. So you can just go and create the Coinbase account, and you can try to see, okay, if with your friend what is his hash public address, and just copy that public address, then it will display. If someone is doing the transactions over the Bitcoin, then it will display, yeah, someone somehow few transactions happened on that particular address. If not happened, then it will no transaction, it will display there. I hope you got it. So if, yeah, some questions I think I'm able to see. More secured blockchain, but why it's not shows the transaction detail like a form who and whom? That is a good question. Actually, why it's not showing? That is the why actually not showing, because in the Bitcoin, once you will download the application, they will not ask you the what is your user ID, what is your name, what is the password. That is the given the random public address and the private address. So once you will delete, once you will format your Bitcoin, like once you will uninstall your Bitcoin, then next time again you will going to download, then next other random like a public address and private address will be generated. So make sure once you are going to uninstall, then private keys is very important for the recovery of your wallet. So many times you heard about that. Oh, actually he loses like a million of the like a 10,000 Bitcoin he loses because of he forget the private address or something. So these things can be happen, and like many Bitcoins is actually in the transactions pool, but that is a non-recoverable. Why? Because that persons, they don't have a private key, they forget the private key somehow, or something can be happen. But I think that is a BIP one, is the Bitcoin information provider, that is the BIP one community was there. Now he's trying to improvise the Bitcoin. There is a community is trying to improvise those concepts. How can we, at least because user ID and what a person asked, right? User ID and the password, that is a very important thing. So user information is very regular, whom and who is the person of that. So that is a very important part. But till now, that is no such concept is there. Yeah, other question. What is the Coinbase value shown in the screen? So this is the random. What I shown in that is a virtual demo. That is not a real. That is a, you can say that is a dummies currencies and all. So here is a given in the terms of the dollar. But that is a, is depend to you. If you, and also like Bitcoin, Ethereum, Lithium. So also you can create your own currencies as well. There is a, you have to write the smart contract for that. That is a long process. That is not easy. But again, the thing is that I want my next demo, actually what I want to show you, that is called how can you set up this Bitcoin wallet on your Raspberry Pi, and what is the main purpose, what is the main purpose to install the Bitcoin wallet over the Raspberry Pi. Actually what I want this, if you remember, like many times you say that is the machine to machine transactions can be happen, like a machine itself do the transaction, no need to do the physical money or something like that. Suppose you went to the petrol pump, I want a 1 liter petrol, then automatically once 1 liter petrol he will given, the sensor will detect, okay, 1 liter detected. Then after that, car itself, it will through the transactions can be happen to that particular pump. So something like that I want to develop that concept, but still is under the process. So only I will show how can you download that particular wallet over the Raspberry Pi. So meanwhile, if you have any doubts here, then you can ask me.
So, yeah. Kishan, just time check. Can you just show on the Raspberry Pi, please?
Yes. So almost is done from my side. Yeah. This demo is done. So now I'm. Yes, correct.
Thank you. Yeah.
So okay, now I'm moving on. So basically I want to show the little bit infrastructure of the Raspberry Pi. Let me on the camera so it will feel good. So okay, let me IP camera I want to on. It's going to be on. Start the server. My server IP is 192.168.5:8080. Yeah. So basically I am using here camera, my mobile phone camera. Now you can see on the screen, this is camera is on. Now I am going to explain you how it's working. Okay, just a minute. So this is my IoT development kit, if you are able to see that one. So these all are the sensors available. Right now there is a in this demo there is no such uses of the temperature sensor, light sensor, ultrasonic sensor, gas sensor, and this is the soil moisture sensor. There is no use. Basically, I am using here the Raspberry Pi. This is the microcontroller that is called Raspberry Pi 3, and here I downloaded my things. So basically, that is called Bitcoin wallet. So what is the process and what are the things are there? I will show you step by step. So this is the LCD display also. So basically, what I want to show you through this demo. So this is the Raspberry Pi, and I am installing to the Bitcoin wallet. So any transactions will be happen, like any sensors will sense something, then one transactions will be happen to the other Raspberry Pi, other sensor, because obviously every machine have a one microcontroller, then only machine to machine transactions can be happen, right? So this is the basically whole idea, but I will explain you the one part of that. Okay, so you clearly can visualize. Okay, now I am stopping the screen sharing here. Okay, fine. Yeah, so I'm just trying to, so basically now for this one I'm using the VNC viewer for remotely access to my Raspberry Pi. So now I'm going to connect my Raspberry Pi here through the VNC viewer. It's sending network connection request. Now you can see that is the user ID and password. So user ID by default is giving Pi, so I didn't change, and password is Raspberry whatever. You can change as well as according to the So this is the beautiful screen. It's given by the Raspbian OS. So you can see this is the whole setup of the Raspbian OS. You can see, and you can write the programs and all those things. Basically in the console system, you can see there yesterday I was tried a lot, so trying to install. So basically these are the steps I will mention later. So here I will show where is the source code, actually where is the Bitcoin. So this is the basically whole code, whole PS is downloaded. It took almost 4 to 5 hours to download the whole node, and might be definitely it's not like a whole node is downloaded, because obviously because of the it's a lightweighted Bitcoin nodes are available. So you can see there is a whole automation that this one configured log files. There is a multiple files is available. No, source, share, src folders. One more things I want to show, that is all the database. What if the hierarchical things is there, db, build file, and other. These are the same like SQL. So basically in the also here there is a database SQL they are using. You can see there, and other stuffs. Okay. So these are the things, and yeah, now I'm going to show you the steps how you can download the Ethereum wallet. That is a little painful process because it took too much time to download, and internet connectivity also required very fast. Yeah, someone is asking something. Okay. I will give the answer in the last, if I will give the time. Okay, now I'm just opening my document. If you are able to see my document, this is the whole process. If you want to take the screenshot also, you can take the screenshot, no issues. So that is the updated OS install on the dependency. So this is the basically I'm doing sudo apt get update. So what is that sudo apt get? So basically before installing anything, we have to update our Raspberry Pi, each and every software, firmware, and all those things. It should be very updated. Then only, because sometimes compatibility issues will come if you will not do the update and upgrade things. So you have to give the first command sudo apt get update, and the second one is the sudo apt get upgrade. And after that, some additional dependencies are needed to build the Bitcoin client. That is the some dependency as written there. That is a few libraries is required to smoothly run your Bitcoin wallet actually. So this is the basic command. And what is a sudo? Sudo is nothing but that is I'm giving the user permission. Like if you can see, right, run as the administrator, something like that. So user permission, for that I'm writing there the sudo things. And after that I created and all those things through the command window. Then it's very easy. Obviously there is a GUI is not there, then you feel little bad. Okay, something is not visualized, but all the things is happened by the command prompt actually here. So now you can see that is a make directory I created source, and inside the source actually after that I went through inside the source, and inside the source I downloaded Oracle Berkeley, this library, this zip file, and after that I extract and I install it. So basically in this Raspbian Berkeley database does not have the play with the Bitcoin client. So basically for the installation of the Bitcoin client, we required this database, database to need to compile our own actually. So we no need to depend to the other compilers or such type of thing. This is the installation process. You can see here, that is how can you install the Bitcoin. Sometimes if you get the error, then don't be panic. Just try to resolve, just try to see the error, and just try to in the different way. Also there is a community, is there Bitcoin community, they will also try to help you. So this is the CD source, again you have to write, and after that in the Bitcoin Git I downloaded this one. So I will show you what is exactly this one. Yeah, so these are the things. So this is the GitHub, and this is the whole basically GitHub I downloaded. So these are the whole code, test, client, and build, all the things are available. So you can get the description also, Bitcoin core integration and staging trees, the development process, how can you do testing, automation testing, and translation. Please go through this document. I will not take too much time over here. Yeah, how many times? Okay, now it's almost.
So
okay.
Yeah.
Okay, just 1 minute, sir. Almost is over. Yeah. Okay, fine. And these are the last configuration setup, and this is the auto gen and sh. So this is source file it will be generating, and after that I am trying to making it. And after this command sudo make install, it will take almost 5 to 6 years. That is the basically you need a very little patience, and just watch what is the things. Almost I hope all things are very smooth, and after that you are able to fully wallet is installed inside your Raspberry Pi. Okay. Thank you. Yeah, sir. Now you can use.
Okay. All right. Thank you, Christian. Thank you so much. So now I just said that one small demo. Actually, some of my Raspberry Pi here, whatever I'm showing it, I'm not able to see the screen. But I'll just very quickly open up the ThinkSpeak. I think somebody was asking me. Quickly open up that and show that again, and then we'll wrap it up. Okay. I know you got a presentation.
Okay. So now I'm stopping the sharing screen. So now you can share. Yeah.
So very quickly I'll show that, then I will give my contacts in case if you need to have other stuff, we can always speak. Okay. So you can see my screen, right?
Yes, sir.
Okay. So this is what the whole ThinkSpeak is there. It's a very easy process. I just uploaded here. I want to go to, so for example, already I have downloaded some of the applications on my channel here. So these are
sir, actually, so we are not able to see your screen, sir.
Sir? Screen is not visible, sir.
Yeah, I'm hearing it. Okay. Sorry about that.
Yeah, thank you. So now it is okay, sir.
Okay. So this is that things if somebody is asking. So basically it's very simple. So when you go to this API, it will tell you the which my channel here, and then you go to that API, all apps. I'm sorry, not this 1 second. My channel, and then so there are various APIs you get from here. New channel. If you want to create a new channel, you create a new channel here, and then you can add the number, whatever you want to do, that news channel number here, name here, and then you get if it is an MQTT, then you can go get your MQTT APIs from here, this one, and take this MQTT API, take it back to your Python code. When you write the Python code, I didn't show the Python code. In the Python code, you have to insert that. You need to route that whatever the flow is there, output is there, to this website. Then it will come to this ThinkSpeak website. And a very simple process is there. I thought I'll connect my Raspberry Pi. I don't know where the code is there actually. I need to identify the code. We have been doing workshop for last 1 month continuously workshop. But I'll be happy to show that. I'll give my contacts in case if you're interested. I will be happy to set up and show that demo to you. Okay, so with that, I think we are out of time here. I don't know how much time we have question and answer. So over to you, Professor Divya. I'm giving my contacts here. So you can contact me at our corporate address here. Or you can contact Kishan also here. Yeah, let me know. We can always try to help you. Okay, over to you, ma'am. I don't know if you have time to questions. I know you got other steps, other conference coming up. No? Any questions?
Hello, sir.
Anybody here?
Hello, sir.
Yes.
Sir, there is 20 minutes time to question and answer. Dear participants, if you have any questions, please ask, sir.
No, let me see here. So till what time? Sorry, I misunderstood the timing here. It is from 12 to 1:30, no?
Yes, sir. 12 to 1:30.
Okay, so timing is only 1:07 actually, yeah.
Oh, I'm sorry. I thought I'm running a little bit of I think my clock was a little listening. Okay. Yeah, we can take questions then. Yeah, right. Krishan, meantime, can you please log into your Raspberry and show some the temperature, humidity, and that code, please? Yeah.
Yeah, actually, basically I can explain the little bit, temperature, humidity, how we can writing and all those things. So can we show the other demos? So basically, if they want to, okay, fine. So basically, we have already login this thing. So earlier, actually, what we created, so that is the little bit, agri-food management system. So what is the basically concept of the agri-food supply chain management? So once any things will be happen, then how can we know about the organic food and all those things? So what is the purpose here to showing that organic food? So sometimes what happened. So
no, Kishan, I'm sorry. No, somebody was asking you for that temperature and humidity on your Raspberry Pi. Can you open up the Raspberry Pi and show that code there? And if it is not there on the ThinkSpeak, we will try to configure it.
No, sorry. Okay, so let me share the screen. So you can also see the screen. So you can also, yeah.
I'll stop sharing.
Yeah, no, already I'm sharing my screen.
No, okay,
are you able to see the screen?
Yeah, right, yeah.
So these are the things. Okay, fine. That's so. So basically, these are the codes. So he wants to see this one blockchain, not this. Okay. Real-time detection UV dots.
Okay.
So UV dots is okay for users?
Yeah, anything cloud they want to. There are 2-3 questions, right? Yeah.
Okay, fine. So now I'm open these things. UV dots. Basically, this is here I am using the UV dots cloud, same like what earlier sir told, right? That is called what is the name of that?
ThinkSpeak.
ThinkSpeak. Yeah, sorry, ThinkSpeak. So similarly, that is the UV dots is the other cloud is there. So here you can see I am using the few libraries for the UV dots API client and all those things. And here the sensor library I am using, that is called Adafruit DST. And these are the variables address. You can see there the API keys and API get variables. Variables is nothing but that is your sensors actually. So once you want to send some sensors value over the cloud, like it might be your ThinkSpeak, it might be your UV dots, it might be your AWS, any cloud. So right, so here we are using the variable name. So you can see that is the variable API address I'm using. So here I'm using only temperature and humidity. That's why I took the only 2 variables. If you want to use light sensor, gas sensor, and other sensors also, then you can use the multiple variables as well as. So you can see this is the IP address. So this basically this is the key basically. So you can paste every variables what you generated, like a temperature variable, humidity variable, gas variable. Then you along with that you have to give this key. So it will push the data over that particular model. So again, now is coming how is a value. So this is a very simple code actually. You can see here. This is the variable 1, variable this is the value, something like that, and this is the temperature value. This is the humidity value. Let me run this one. So let me check it's working fine or not. So here the things are available. Now it's some coding issue. Okay. So let me open with the command line. So everything like normally, if you remember what we are doing. So once we are running any project or any Python script, then we have to go inside the folder. Okay. So cd enter, cd enter. So what is the path? Here you can see that a home py desktop. So already we are inside the home py. So only we have to do cd desktop tab enter, cd that is IoT show, and that is the cd without tab. Sorry. UV dots. Okay. Now let me try how you can run this program actually. So for the running this program, that is called sudo http tab uv dots send tab dot py. Let me see what is happening. So almost that is running. Now you can see that is the temperature and humidity and value sent, right? So what is the temperature? So that is the temperature right now. It's showing 31 and humidity. So once we'll do some temperature we want to increase, then usually what we are doing actually we are using hair dryer or something. So it will be very fluctuation. You can see over there. So now value is sent. So if you want to see the screen, so exactly, so I not remember so which account is sent it, because earlier we created, but anyway I will give the little bit cloud idea how it's working. So this is my UV dots account. So in the UV dots, basically this is the cloud. Can I go ahead, sir?
Yeah, please go ahead.
Yeah. Okay, thank you. So you understand in the coding side, right? So basically all the coding part we are using by the Python, and after that we are sending the data. It might be a sensor, it might be actuator, any action you want to do, then all the things you can do over the Python. Obviously I can't go through all those things, but okay, at least you will get the better idea over here. Now I'm trying to do the login over here. So this is the basically UV dots cloud. I like so much UV dots because there is a lot of functionalities over here. They can send the data and you can get the alert messages and lots of many things. So this is the something. Okay, I will just going to log out and again I'm going to be login. Yeah. So this is
right. Thank you. Yeah, Christian. Yeah, you can get the UBI account if you remember that. I know we have been getting so many workshop done. We have created so many accounts.
Yeah,
so you can get the UBI account. That is good. Otherwise, just our goal was to show you that how it works. Now you already saw that Kishan's demo, right? He showed you how that the Bitcoin can be implemented on this Raspberry Pi. Instead of this, you are getting that Bitcoin that address. He showed that earlier. So we connect that data to that cloud. So that is how it works. So, I mean, anybody, it's a very simple process. As long as you know the Python code. See, now you use the UBA dot. You can use similarly for the AWS also. Last week we demonstrated AWS. This week also we are demonstrating in one of the other conferences there. So again, processes is that take any hardware platform, get the underlying software. I mean, we use on the Raspbian itself, and then get the Ethereum or whatever the software you want to get it, upload it on underlying the OS, and then you can start writing the code and send that data. Now our goal is, so how do we make it a blockchain compliant sensors, right? I mean, because we are taking as a, like Kishan showed, no, Raspberry Pi is taken as one node, right? Inside that, all these small blocks, what we showed. Remember that earlier I showed that block, so how to show that. So let's see if we can still get that UBA dot accounts. I know it's hard to remember. There are so many projects, so many demos. They're all dynamic. Every time we do it and we just we don't erase it. We just keep it there. So try your memory, Christian.
Little voice is breaking.
My voice is breaking.
Yeah, for me. For me, I think I don't know. Yeah, can you repeat what it is?
So can you are you able to get that UBA dots there? Yeah. Is my voice is clear, Dr. Professor Bhavya?
Hello, sir.
Professor Bhavya, is my voice was clear, right?
Yes, sir. It's clear, sir.
Okay,
yeah,
fine.
Christian, what I was saying is that that UBA dot, if you remember that, otherwise just show the website,
Yeah, no. I have credentials and all those things. So basically, this data is sending in the other's user ID because I forget that particular user ID, but I will show you that one.
Okay, you can add this API into that. Okay.
Yeah, otherwise I can add this same API and I will create the variables and I will send to them. So that is the whole process also audience can understand. That is a very good idea.
Absolutely, yeah. See, so it's a good opportunity for audience. You can just see he's creating that, taking that API from the UBA dot, like ThinkSpeak what I showed, and adding into his Python code, and then he run the program. You get it on the UBA dots here. Yeah.
So basically, this is in the gas leakage workstation monitoring. Inside the workstation monitoring, I will create. Otherwise, I will create in the device. Okay, let me create the new device. Okay, so these are the things. So here I'm just trying to create one more device here. That is the blank event. So basically what is happening here, every events, for you want to create the events, then you have to create your own application, right? So own application is like your smart agriculture, smart bin, or whatever. So I just giving the here now name is that a smart room, something like that. I'm just given the name, and that is the smart room name is given. And after that I'm just going to create. Then you can see that is a blank device is created, and after that I'm hitting over the click. I will do little fast because we have less time and we have a few steps, so just try to observe all those things. Okay, so now you can see there is a smart room is created over the device. Now inside that smart room I have to create the variables. If you remember that in the earlier code, I told you, you have to set the variables. If you want to use the temperature sensor, then you have to create the temperature variable. If you want to create the light sensor, then you have to create the light variable. Then you have to create over the add variables, and you have to click over there. And after that, the temperature name you have to give, and hit the click. And after that, the one other value name is that is the humidity, correct? So I'm just giving the name humidity over there. Then second thing is done, right? So now you have to click over the temperature and you will get one variable ID. So that is I'm talking about. This ID you have to copy over the code. So this is the my code here, and here variable one, basically that is the temperature, I'm pasting here. So this is the things is done. Now I have to take the second variable, that is name is that this is the temperature. Yeah. So now this is the variable, that is the humidity variable. So now you have to copy this humidity variable, and after that you have to paste inside the VNC. That is the variable 2 basically. Okay, paste. Now it's the application token, API token. You have to do that one. Okay, the same one. Okay, fine. These are the same one. This is the, you can see that is the different IP address is created. Now I'm going with the token, API token. So this is the admin users. Okay. So now you can see this is the default token. Now this is a copying this one. Now it's copied default token, and I'm pasting over the here. Now this is I'm going to be paste. Okay. It's not. Okay, it's not pasted here. Okay. I think that is in the VNC viewer. There's a pasting is little problem. Okay, now it's pasted. Okay, fine. Now I have to paste all the things that is not taken by the things, but okay. Anyway, I will just go in the devices. So these are the device. Again, I have to paste the variable because it's not pasted properly at that time. Since this is my smart room. My voice is clear, right? Audience, please just tell me yes or no.
Yes, sir.
Yes, it's clear, sir.
Okay, and speed is okay, right?
Yeah.
Okay, fine.
Yes,
Thank
Not
you.
a problem.
Thank you. Thank you. Thank you. We have a little time sorted. That's why I'm a little doing fast. That is okay. Please. So here I'm trying to paste that one. Let me delete first, and pasting is a little difficult here. So yeah, oh sorry, again it's not taking properly. Again I have to copy. This is the problem sometimes I have to face. But anyway, I will try once again. Copy and paste. Okay, this time it took. Again the second one, that is the humidity. So where is the humidity? This one. And here this is my ID. This is the correct, and this is the I did the copy this one, and after that I'm doing. So paste. It's done. No, it's not taken actually again. Okay, anyway. Yeah, okay. Paste it. Control. Yes. And this is a 79E. I am checking once again that is a correct or not, because sometimes if credential is not correct, then we have to face the issue. That is also not copy pasted. Again, that is a problem for me. Okay, this is the right click, copy, and again I have to paste here. Wait, let me delete first. Fine. Now I have to do the paste. Oh shit. I have to facing this. Okay, I'm just trying once again. Let me check it will work out or
So
not.
your code is showing the data center cloud, or still?
Yeah, I'm sending the data in cloud, and actually for the copy paste I'm facing the issue. Sometimes it's copying full, or sometimes it's not taking the copy properly.
Okay.
That's why I have to
What I
again.
would do is that I would just paste it on a notepad, and from notepad you
Oh,
copy
okay.
it. Yeah.
Yeah, now it's okay, fine. Now it's workout, and now I have to do the save. This is the process, and all the things is okay. Now I have to run the code. Already in the this is in the command prompt. Only you have to do this Python send, right? So let me check temperature and humidity should be what value sent. Okay, now I have to see here what is the value is coming or not. Loading the variables. Now you can see that is my value. Humidity is 72 and temperature is 31, right? So basically this is the process actually sending the data over the cloud, and there is a many things like not only you can sending the data. Yeah, are you able to see that one?
Kishan, can you just show some graph also for them to understand the graph?
Yes, graph. Yeah, for the graph you have to create the dashboard for that. So for dashboard you have to go in the data dashboard, and you have to create the dashboard. Again, it's depend to you what graph how you want the data, in the form of the graph or in the form of what. So basically in the form of graph you have to create, there is a multiple things are there, right? So basically you want in the double axis, right? Correct. Histogram I want. So basically I am adding the variable here. So that is the smart room. This is my device, and inside the device I want to show the temperature basically in the graph. So this is almost going to be done. Now I'm clicking over there. Now you can see this is my first temperature value sending. Got it? Are you able to see, audience?
Oh yes, great. Yes, we are able to see that.
Okay, fine.
So that's exactly we want. Yeah. So this is what we just wanted. Thank you, Kishan. So this is what we wanted to show you to all how this thing is coming. Okay. Now there's a question that what is the role of blockchain over here? Yes, role of blockchain is that, like Kishan showed earlier, we want to implement that blockchain and make sure it is securely connected into the node. Which we could not do the demonstration. This demonstration we are doing, the several questions came in the first session, right? They want to see demo. That's why I thought it is worth showing to some people who are interested in that. Definitely is not a complete blockchain, but it's an IoT, the first part one. And then there's a question, Kishan, you are able to log in your Raspberry Pi using the VNC?
Yeah. Already is in the login actually. Yeah.
This is the Raspberry only. What are you showing it?
This is connected to the Raspberry.
Can you show your code? And somebody is asking that where do you insert that your the API? No, can you show them the code? Go to the terminal mode.
Already I shown them actually. Here only I did all the changes actually.
So no, they want to know that the UBI dot, where did you insert that code? You know?
Okay. This is the UB dots basically library I added here. You can see there from UB dots import API client. Are you able to see the audience? That is the basically things is there.
You go where is inserting? Is it? Can you please go to your code? You know, is there in the desktop or where is that code? Your Raspberry Pi, please.
So screen is not visible there. Actually, I'm open.
UBI dot we are seeing it. I'm seeing only UBI dot. I'm not seeing your Raspberry Pi.
Okay. Sorry. It's my mistake. I'm sorry. Actually, I'm sharing the only UB dot. That's right. Okay, I'm stopping the sharing the screen and again I will share that one.
Yeah, go to your Raspberry Pi.
Yeah.
See, again, no, this is our virtual lab. You know what he's doing? You know, he's using this desktop or laptop and logging into Raspberry Pi. That is a virtual lab, right?
Yeah. Here now is able to see.
Yes. See.
Okay. I'm so sorry. Actually, that screen is not moving here and there that time. So I think you are facing little issues. Okay. I'm sorry. Actually, I did all this.
I don't see his or her name. User 74 asked this question. So just to show that, you know, what is that API variable here showing here? Yeah.
Yes. Okay. Now I think you are able to see my coding part, right?
Right. Yeah.
Yeah. So basically, you can see here that is the from UB dots, and that is the import API client is there. So UB dots, that is the providing his own library. You have to just download. That is the command is nothing but that is a sudo pip install UB dots. That is a simple command. And after that, Adafruit I'm using for the temperature sensor. That is the library. There is you can call the temperature sensor and humidity values actually. So these are the things, and this is the basically main responsible things. That is the called API token. So API is nothing but that is you remember I copied always API keys and all those things. That is basically BPFF. That is the API key device ID you have to create, and after that again you have to in the variable one, that is nothing but that is your temperature. So this ID you have to copy paste it here. So it will be now linking to your UB dot. That is the basically linking part. Sorry, that time screen is not moving. That's why I think you are not able to see how we are doing the copy paste work here. But anyway, this is the basically process, and this is the variable, and this is in the last you can see variable one dot save value and value equal to temperature. So this is the basically ID. Name is the temperature. You can see there is a name I written temperature. So inside the temperature, that value, whatever the value is sensing by the sensor, it's sending over the cloud. That is the 27 or 30, whatever the value you got it, right? So that was the value is sending over there. So this is the whole code. If you want to add the sensors over here, also you can add that. I added only the variable 1 and variable 2, but also you can add multiple variables, like a variable 3 can be light sensor, variable 4 can be gas sensor, and all those things. And again, one person asked about the questions, how we can relate to the blockchain. Obviously, that is the part of IoT. So what you have to do, if you want to this value stored inside the blockchain, again you have to give the blockchain references and all those things. The process are the same, only the thing is that you have to give the change the some tools and all those things. Yeah, hi sir, can I explain that one?
Yeah.
Okay, fine.
Yeah, sure. I think that's great, Kishan. Thank you. Anyone got any last question? I think I know we are now running out of time, but definitely we can encourage any one or two questions, or you're more than welcome to approach us anything with that. Any final questions? All right. So over
Dear
to
participants, if you have any questions, please raise the question. Please raise the questions.
Okay. All right. All right.
Sir, there is one question.
Yeah, sorry, there are some questions coming up now. What time interval of Okay, so do you control to which block of the IoT data gets stored? Let's see here. Do you link with yes, that is the goal actually. We want to link all the data to the Ethereum. So that is where we could not do it on the Raspberry Pi. What is the UBA dot? UBA dot is another cloud, like ThinkSpeak or an AWS, And then what is that? Sorry if I miss anything. What time interval of the temperature value? We can always define the time, in the Python coding, you can define what time you want it. These are all scientific sensors, not a production. There is some delay will be there, when uploading the data, when responding, because they're all semiconductor, right? There is a response time is there inside. There is a semiconductor is there inside. So, do you control to which block data gets stored? That will be answered. Intro, that also we answered. And so much the response for okay, that's good. And then Adafruit, yes, we can use the Adafruit. In fact, we use the Adafruit library only there. All right. Hope it was a useful session, and let's know how we can work together in the future. Okay. Can we one more question? Can we change the name instead of Python? Can we change the name instead of variable? Yes, we can definitely. So then informative. Okay. All right. So yeah, over to you. Over to you, to Professor Bhavya.
Sir, hello.
Yes.
Sir, thank you so much for wonderful and excellent session, sir. So demo session is very good. Thank you so much, sir, for presenting the demo.
No problem.
Hello.
Yes, ma'am. Yes, yeah. Okay, let me just show some thanks to everyone there. Okay, yes, ma'am. Okay. Yeah.
Yes, sir. Thank you, sir. Thank you so much. And demo session is really, it's very good, sir. Thank you for your patience, sir. For explaining all the things for blockchain and IoT, connection of blockchain and IoT. Thank you, sir. Thank you so much, sir.
Okay. Thank you so much. Thank you, everyone. Have a good rest of the sessions. Thank you so much.
Thank you, sir. Thank you. Dear participants, afternoon.
Madam, your mic is off. We are not able to listen anything.
Hello. Now it's audible, sir.
You can.
So, dear participants, the afternoon session will be at 2:30. So please, all of you join at 2:30. Which is in the calendar. So all of you please join the time which is given in the calendar at 2:30 session. Thank you so much.